Hello and welcome. A very good afternoon to all our students who are part of this session today from all parts, all portions and all corners of the country. Welcome to today's session, and today, the 22nd of July 2020, we shall be focusing on progressions and we will be discussing in detail on geometric progression GP. Before we go into that, I'm sure that all of you are keeping fine and you have been practicing the problems. Last day, you may remember, we completed the arithmetic progression AP and number of queries and questions have come, which I shall be taking up. But first, let us see the plan for today. First, we go into the marks weightage and the marks distribution in the exam. And I think that is something which everybody is thinking, that which chapter is going to be the most important, right? Some people may think of selective preparation, leaving few chapters, but my request, please do not go for any selective preparation. You must study and complete all parts of the syllabus equally, because questions might be coming from all corners, all parts of the syllabus on an equal basis. So the distribution of marks will be quite, I would say, uniform, and therefore every portion of the syllabus is important from the question point of view. So please keep that in mind. First, we'll go into the discussion of the weightage of different chapters in the exam. Second, we will move into geometric progression. We will see the different important formulas, the concept of geometric progression, GP, and then we will discuss about GM, which is called the geometric mean. Friends, you may remember last day I discussed about arithmetic mean. So today we shall be discussing about geometric mean, GM, and then we will do number of problems and their solution in front of you so that you can learn step by step, and the exercises I'll be taking up will be from the study material, as well as I'll be covering few additional questions and questions which have come in the MTP, that is in the model test paper of the Institute of Chartered Accountants. Friends, we shall also revise number of problems on arithmetic progression, because that is an area where few of you have problems and you have sent certain queries to me. Certain examples I'll be doing once again, especially with regard to some specific problems which are a little bit tricky, and since we have almost more than 2 hours, we shall be first moving into GP, then we shall move into AP and do the revision part, okay? But first and foremost, let us have a look at the weightage of the marks. Friends, we are now almost towards the end of our mathematics syllabus. You know the entire paper is divided into 40, 40 and 20. So business mathematics is 40 marks. Logical reasoning is 20 marks and statistics is 40 marks, right? Now we are reaching towards the end of the mathematics part. We are now left with sets, relations and functions, which we shall be doing tomorrow, 23rd of July. And then we shall move into differential calculus on 25th. And on 27th, we shall be completing integral calculus. So your mathematics portion will be over. After that, we shall be moving into logical reasoning, and thereafter we will move into statistics. That is the game plan, that is the agenda, that is the sequence in which we shall be proceeding. Okay? Now, first we look at the syllabus, and now let us see the marks distribution for the mathematics part first, because mathematics we are almost completing. So first, if you see, part 1, the mathematics portion is divided into 3 parts, and please note that our institute has brought out this important weightage of marks specifically for the exams, that is the foundation exams starting from November onwards, November 2020 onwards. So this is the revised scheme of marks, the revised distribution of marks, which is going to be very, very relevant for you. It's going to be very, very important for you. So we have divided if you look at the way in which the structuring has been done, the entire mathematics portion has been divided into 3 parts. Part 1, Part 2 and Part 3. Part 1, if you see, will be carrying weightage of 20 to 30%, right? So please note 20 to 30% is the weightage of part 1. Now, what are the chapters we have in part 1? The first is ratio, proportion, indices and logarithms. Now, in case of ratio, proportion, indices and logarithms, which you have completed, now we have the business applications to ratios and proportion, laws of indices. You may remember AM into AN is equal to A into M plus N. The laws of indices, that is included. Exponents and logarithms and anti-log. These are included under the first, that is the first part 1, the first part, ratio, proportion, indices and log. Next, we have equations, that is linear equations. You have quadratic equations, right? And then you have matrices. These have been covered in detail. So you are aware about equations, both linear equations as well as quadratic equations. And therefore, I think we have discussed in detail also about matrices, and we have tried to solve as many problems as possible. So therefore, equation and matrices, please note, is a very important part of this first part, and therefore you will be expecting questions. Third is linear inequalities. Linear inequalities we have done, including the graphical part. Please remember there is a graphical portion which we did, and therefore that is equally important. And these together would be comprising part 1. So please have a look. Under equation and matrices, we have linear simultaneous equations up to 3 variables, quadratic and cubic equations, right? So cubic equations in 1 variable, that is x cube. You remember the equation x cube plus 3x square plus 6x plus something. So you see, that is the cubic form. So that is included. In case of matrices, specifically if you look at matrices, now what are the areas which you need to study? First and foremost, the algebra of matrices, number 1. Number 2 is the inverse of a matrix is included, inverse. So we did the adjoint matrix, we did inverse of a matrix, and you may remember we also covered determinants and Kramer's rule, and that was done in details. So that is included in matrices, and therefore please go through the adjoint of a matrix, inverse of a matrix, minor and cofactor, as well as solving linear equations using Kramer's rule, right? We did Kramer's rule both for 2 variables as well as for 3 variables. So I hope you remember it. That is under matrices. Next we move on to the linear inequalities, in which you will be having linear inequalities under only one unknown. That means where x is unknown, only one unknown will be given. And you also need to make sure there is one variable, linear inequalities in one variable. And please make sure that you are having good knowledge about the graphical way of solving inequalities, which we covered also, because that is included under linear inequalities. So the graphical method is also important for your exam. Friends, next I move on to a very, very important part of the exam, and a very, very important chapter. Perhaps you can call it the most important chapter, and this is the time value of money, right? Please note that from this particular section you are having, this is part 2, and you are getting 30% to 40% of the marks. The questions covering 30 to 40% of the marks will come only from the time value of money. Now, what you have in the time value of money? We spent 3 complete sessions. In fact, we worked beyond 4 o'clock all the days, and we covered time value of money in great detail. It is one of the most interesting chapters, and a particular area from where maximum problems will come in your mathematics paper. So what are the areas to be revised? Please keep a note. First, simple interest. Then you have compound interest. The third is annuity calculations. So we had 2 types of annuity, annuity regular and annuity due or annuity immediate. That is included. Then perpetuity. You will remember we did the perpetuity formula. we had two formulas, one for simple perpetuity and one for perpetuity where there is a growth, right? So that is also going to be an important part of this chapter, time value of money. And you have the effective rate of interest, 1 plus I to the power n minus 1. You must be remembering that we did the effective rate of interest. That is included. Present value calculations is included. And nominal rate of return, effective rate of return, and the compounded annual growth rate, CAGR. This will be included. And when you talk of present value, you can understand we had discussed number of problems on the net present value, NPV, right? So that is going to be included within this chapter, and this is part 2 of your exams. If you look at the structure of the exam questions, and 30 to 40% marks will be coming from part 2. Dear friends, I move on next to part 3, and the third part, 30% to 50% weightage has been given to part 3. So part 1 is having 20 to 30% weightage, part 2 is having 30 to 40% weightage, and part 3 is having 30 to 50% weightage. Now here we have a number of very important chapters, and we have completed many of them. Now, permutation and combinations. We have done, under permutations and combinations, we have done factorial. So what are the areas which you need to revise, right? So I'm discussing step by step, part by part, portion by portion. For permutation combination, what you need to study and on what areas you will be expecting numericals. Number 1, factorial. Number 2, NPR, the formula for permutation. Number 3, circular permutation. You may remember that n objects can be arranged in a row in factorial, n factorial ways. But if the same objects are made to sit or are placed in a circle, then you have n minus 1 factorial. So this is important. Plus, please remember permutations with restrictions, which we did, and combinations. So NCR, combinations, standard results, and how to differentiate between permutation and combination. Those are important. So please make sure that you have adequate knowledge and you have solved a wide variety of problems, both from the exercises, both from the MTP, the model test paper, the additional question bank, and if you get through, please go through the past year's questions also. Okay, so this is going to be the permutation and combination portion. Next, I move on to sequence, series, AP and GP. Sequence, we have discussed in the last day. Sequence is something which is a set of numbers. It is again an array of numbers, an arrangement of numbers, a collection of numbers, which has some pattern, right? I discussed about TOP, top, T for trend, O for what? You remember? O for order, and P for what? A pattern. So, this is important. And what is sequence and what is series? Sequence is fine. If I write, say, 3, 5, 7, 9, this is a sequence. What is a series? Series will be if I write something like 2 plus 4 plus 6 plus 8. So, the sum, right? The sum of all the terms of a sequence is called a series. So, sequence, series will be there. Arithmetic progression, please note I have written the formula here so that it helps you. Now, what are the formula which you need to remember for arithmetic progression? Specifically, I have written the formula here because we have covered AP, arithmetic progression, on the last day, and today also we shall be revising few of the problems, plus we shall also discuss about some more questions on AP. So first is nth term, Tn, a plus n minus 1 into d, where a is the first term, n is the number of terms, and d is the common difference. Right? 1, 3, 5, 7, 9. Here the common difference is 2. Right? And a, that is first term, is 1. So this is the first formula. The second formula we did was the sum of the n terms in an arithmetic progression. So the sum is given by n by 2 into 2a plus n minus 1 into d, where a is the first term of the progression, n is the number of terms, and d is what? D is the common difference between the terms, right? T3 minus T2, T10 minus T9, right? So a particular term minus the preceding term gives you the common difference. And we know in case of arithmetic sequence, or if I say arithmetic progression, these differences will be constant, will be equal, will be the same. Okay? So these two are very, very important formula. Now we go to some additional formulas which we discussed. Now for odd numbers, I will first come to number 4. You remember I discussed last day a shortcut formula. Okay, you always have this formula, fine. But then for exam purposes, if you are given something like say 1 plus 3 plus 5 plus 7 and so on. So we have the formula for the odd numbers, which is n square. The sum will be equal to n square, where n is, of course, this is the first n odd numbers starting from 1, 3, 5, 7 like this, 1. So the first n odd numbers. Similarly, if you take say the first n even numbers, there is a formula n into n plus 1. Okay, so this gives you the sum of the first n even numbers, and you know the first even number starts with 2. So 2 plus 4 plus 6 plus 8, for example, if you take the first 4, then you can find out the sum 4 into 4 plus 1. Okay, so in this way, you can find out the sum of the first n odd numbers and the first n even numbers. Some of you are asking me in the query that, sir, what is the formula to be used for even numbers? So this is the formula for even numbers. Next, friends, we did one more formula, and that is with regard to the square. 1 square plus 2 square plus 3 square plus 4 square plus 5 square and so on till n square. So the formula, you remember, is n into n plus 1 into 2n plus 1 by 6. So this is formula number 5, which you need to keep in mind, and questions may be coming from this. And the last one is for the cubic. 1 cube plus 2 cube plus 3 cube, in this way, plus n cube till n cube. Shortcut formula, very simple to remember, n into n plus 1 by 2 whole square. Okay? So these 6 formula will be the basic structure, the basic preparation you can do for this chapter on arithmetic progressions. GP, geometric progressions, we are covering today. So permutation and combination we have done. Sequence, series, AP and GP we are completing today. Now in part 3, if you see, apart from these two, we have sets, relations and functions, which we are going to do tomorrow. So we will study about set theory, Venn diagrams, etc. And last 2 days we have differential calculus and integral calculus. So this part 3, if you see, will have permutation, combination, sequence, series, AP, GP, sets, relations and functions, and the basic applications of differential calculus, applications of marginal cost and marginal revenue. Now many of you, I'm sure, will ask me on the day of the calculus session that, sir, why are we studying this? Like many of you have asked me a very intelligent question. There's some matrix, okay, you told us the application of matrix, but then what is the application of permutation and combination? Why are we learning this chapter? I told you that permutation combination is also used in risk management, in risk return calculation. For AP and GP, equally important. When you want to compare the returns of 2 investments, you need to know the structure, the trend, the order, okay, the pattern. So you need to know AP and GP. Similarly, calculus is important, we will see, because it helps us in analyzing marginal cost, marginal revenue, and these will be included in this particular part, right? But good news for you is, as per what is given in the institute's website, if you see, trigonometric applications are excluded. right? So ddx, differential coefficient of sine x, for example. You remember trigonometry, sine theta, cos theta, tan theta, cot theta, cosec theta, cosine. So these are not included, right? So this is basically what we have for the mathematics part. I shall take up the logical reasoning, and later on, if I get once again an opportunity to discuss about the logical reasoning part and the statistics part, then definitely I'll discuss about the marks distribution for the logical reasoning. It has 20 marks in all, and for the statistics also, which has 40 marks, right? So now let us go back to GP. I'll rub this part. So you can see part 1, 20 to 30%. I hope all of you are clear with the 40 marks which is going to come from mathematics, how it is going to be divided, how it is going to be distributed. So 20 to 30% once again. Part 2, time value of money, 30 to 40%. And then you have part 3, which is going to carry between 30% to 50% of the marks for the business mathematics portion. Okay. So this is the weightage, and we shall discuss the logical reasoning and statistics later when we take up those portions, and you will have clarity about these parts also. But my only request to all of you is, please do not leave any specific chapter, because questions are going to come from all parts of the syllabus, and you know there are negative marks. So you have to take care of two things. One is complete coverage of the syllabus, and number 2 is speed and accuracy. Please take care of that. I'm sure you have enough time before November, and the way we are proceeding, I'm sure every day many of your queries are getting sorted out, and you are getting the interest to take up more and more problems, to solve more and more problems under exam conditions, and make sure you are ready for the exams. Okay. So let's go back to series and sequence, and we will take up GP now, geometric progression. So we saw that if I say something like, say for example, 5, 10, 15, 20, this is something called a, you can call it a sequence. Why it is a sequence? It has some definite rule. You can see that it is increasing, right? There is some order, and some of our friends asked, sir, if there is a decreasing trend, will it be a sequence? Say something like this. Say for example, we have, okay, let's have 10, and then 5, and then a 0, and then minus 5, and then minus 10, like this. Will it be a sequence? 10, 5, 0, minus 5, minus 10, and so on. Yes, it is also going to be a sequence, because it shows some orderly pattern, and the rule is, the logic is, for a sequence, it should have a definite rule or law, and there is a definite value given, plus, most importantly, there is some order, right? Now, this is a sequence. So, it is a sequence. What will be a series? Right? Some of you asked the difference between what is series and sequence. We have some of our friends like Indu R from Salem, Hema from Tamil Nadu, Saurav from Hajipur, Param Singh from Balotra, and Shivani Singh from Kolkata, who were asking me about what is the difference between series and sequence. So this is sequence. Series. Series will be the sum of the elements. So it is nothing but the sum of the elements. Sum of the elements will mean something like this. If I say 1 plus 3 plus 5 plus 7, right, plus so on. This is a summation. This is a summation. This, there is no positive, there is no additional sign, no addition sign. These are just numbers. But this shows that it is nothing but a sum. You can see it is nothing but a sum, because you have the addition sign. Okay, it is a sum. So this type of expression, which is basically a sum of different terms of a sequence, right? This is known as series. I'm writing another example of series. Let's take this one, 2. Okay, minus 4 plus 8 minus 16, like this. Is this a series also? You can see this, 2 minus 4 plus 8 minus 16, and then so on. Is it a series? This is also a series because you can see here what is happening is there is a particular order. In fact, 2 into minus 2 will give you minus 4. Minus 4 into minus 2 will give you minus 8. Minus 8 into minus 2 will give you minus 16. So in fact, this particular series which you see is not an arithmetic progression. This is a geometric progression because the common difference in this case, there is no common difference. In fact, there is no CD. If you see, here we call it the common ratio. The common ratio here is minus 2. That means any expression, 8 for example, divided by the previous expression, minus 4, will give you minus 2. So both of them are series. One is an AP, one is a GP. So this is the essential difference between what you call a series and what is a sequence. So a sequence is isolated numbers which have some order, you can call it. Isolated in the sense that they don't have any additionals, no addition sign, no subtraction sign. They are just collection of numbers, but they exhibit some order, they have some pattern, they have some trend. Okay? But in case of series, some of the elements, when you have the addition sign, only then we will call it a series. So this is the essential difference between what is called a sequence and what is called series. Now let us look at geometric progression. So I'm sure you have gone through all these 6 formula and I'm sure many of you have already memorized them and you must have done numericals, I'm sure, so that you can use these formula. The more you practice, the more perfect you become, and you don't have to memorize in that case. Automatically by reflex, you will be remembering the formula. Okay. Now let's take something easy sequence. Let's take 2, 4, 6, 8. 2, 4, 8, 16, 32. Okay. 2, 4, 8, 16, 32. 2, 4, 8, 16, 32. Then we have, 64 and then 128 and 256 and so on. So here, is this a sequence? Yes, it is a sequence. Why? Because we see some order. It is increasing. Fine. Is it an arithmetic sequence? We know in case of an arithmetic sequence, say this is term 1, T1. Okay, this is T2. Term 2 is 4, T2, T3, T4, T5. So, T2 minus T1 is 4 minus 2, 2. T3 minus T2, T3 minus T2 is 4. T4 minus T3, T4 minus T3, that is 16 minus 8, this is 8. Okay, so is this an arithmetic progression where the difference between the terms is increasing? Can it be called an arithmetic progression? Just think. Can you call it? No. Why? Because we know in case of arithmetic progression, the differences will be the same, but here the differences are increasing. So it is not an arithmetic progression. However, dear friends, if I write, let's take T2 by T1. Now instead of subtracting, I am dividing. T2 by T1 is equal to 4 by 2. 4 by 2. This is equal to 2. T3 by T2. So you have T3 by T2. 8 by 4. 8 by 4. Again 2. That means here, this 2 is same. Again you take T5 and T4. T5 is 16. T5 is 32. T4 is 16. So T5 divided by T4 is 32 by 16, which is again 2. That means here, the common ratio, the ratio between the one term and its preceding term is same. 2, 2, 2 everywhere. In other words, you multiply 2 by 2, 4. 4 into 2, 8. 8 into 2, 16. 16 into 2, 32. 32 2s are 64. So this is called a geometric series where the common ratio. So in this case, this ratio which you see here, this ratio T2 by T1 or T3 by T2, this is called the common ratio. The common ratio. Common ratio. Okay? So, in case of arithmetic progression, in case of AP, we called it common difference. But here we call it common ratio. So, this is the difference between AP and GP. But, please remember, in case of AP, common difference was constant. Say 5, 10, 15, 20, 25, if you go on. Multiples of 5. 5 ones are 5, 5 twos are 10, 15, 20, 25. Here what is happening? Multiples of 5. Is it an AP or a GP? It is an AP because the common difference is 5. But here, 2, 4, 8, 16, 32. This is not an AP, it is a GP because we have a common ratio and the common ratio is same. The common ratio is equal. Okay? So that is why it is a geometric progression, a geometric series. Okay. So you can see the basic difference between AP and GP is that in case of AP, both are sequences. AP and GP both are sequences. Absolutely. But the essential differences in case of AP, we have common difference, and in case of GP, we have common ratio. Okay, I also discussed the last day, you may recollect, you may possibly you will remember, I discussed about two examples. Example one was that if you have two investments, one investment giving you a return of say 5% in the first year, 7% second year, 9% third year, 11% fourth year. And another investment which is giving you 4% in the first year, 8% in the second year, 12% in the third year. 24% in the third year. So 4% in the first year. Okay, so two combinations, two types of returns. First is giving you 5%, then 10%, then 15%, then 20%. Another, say, investment option which gives you 4%, then gives you 12%, then 36%, then 108%, like this. So in the first case you have 5, 10, 15, 20. No doubt the returns are good, but the returns are increasing at an arithmetic progression rate because the common difference here is 5. 5, 10, 15, 20, 25. So the difference is 5. In the second case, you are earning a return of 4% in the first year, but 12% in the second year, 36% in the third year. So here, the ratio is 3. The common ratio is 3. So this type of return is a geometric rate of return. Okay? So definitely when you talk about geometric rate of return, it is very, very lucrative. No doubt. But I also discussed the last day, every type of return, will you call it good if it is geometric? In other words, when you talk of investments, yes, investment you have two options, option A, option B. Option A gives you return in arithmetic progression. Option B gives you return in geometric progression. Obviously, people will run for option B. But I gave the example of the COVID-19 pandemic. In one country, the affected people in COVID is increasing at a rate of say 12%, 14%, 16, 18. That means at an arithmetic rate, arithmetic progression. And in the other country, the rate of the number of people who are getting the COVID-19, who are getting contracted with COVID-19, who are falling sick. Right. Say the rate is 4%, 8%, then say 16%, 32 and so on. So this is not good. So anything which is geometric, any increase which is GP is not good. When it comes to returns, definitely it is good. But when it comes to people living below the poverty line, when it comes to people who are getting affected due to COVID, okay, then GP may not be good. Right, just an observation. Okay, let's move on and let's take now a very important formula. But before that, let's see if we can find out some more GPs, okay, sequences. Let me write another sequence and see whether it's GP. Okay, 1 minus 6, then I have 36, then I have 216, minus 216. Is this a sequence? Yes. Why is it a sequence? Well, you will later on learn that the value is going into positive zone, then negative zone. Again positive zone, then negative. Again positive, then negative. So 1 is positive. Okay. Then 6 is negative. 36 is positive. Okay. So ultimately it moves like this. Okay. So once it is in positive zone, once negative, positive, negative, positive, negative, and it is increasing. Definitely it's like a sine curve. Later on when you study, if you study, sinusoidal functions, sine functions, this is a sine curve, trigonometric, sine theta, sine curve. Okay, even if you study about current, electricity, electric current, alternating current moves like this. Okay, so there is change of phase. So this is also a sequence, fine. Now is it an arithmetic sequence? Please see, is it an arithmetic sequence? The sequence is 1, minus 6, 36, and then I have minus 216. No. Let us see the common ratio. So common ratio is equal to, take any term, I'll take minus 6, and take the preceding term, take the term which is just before. Minus 6 by 1 gives you minus 6. Fine. I will take minus 216 to find out the common ratio. So minus 216. And I take the number preceding. So it is 36. Let me use a calculator quickly. Yeah, here again we have minus 6. So the common ratio is same. So this is a geometric GP, geometric progression. Okay, the common ratio in this case is minus 6. Fine. I'll take another example. Let's take, okay, 2, 4, 6, 8. Will it be a GP? No. This is an AP. Okay. In the exam, when you are ultimately you have time constraint, when you are rushing against time. So many questions, so little time. Oh, run. Right? In that case, what happens? Many people get confused. AP versus GP. But always remember, 2, 4, 6, 8 is an AP. It's not a GP because there is no common ratio. In fact, the common ratio will never be the same, even if you do a common ratio calculation. Okay. The next one let us take is this 1, 10, 100, 1000. 1, 10, 100 and 1000. 1, 10, 100 and 1000. Is this, will you call it a GP? Okay. 1, 10, 100, 1000. It seems that 10 by 1 is 10, 100 by 10 is 10, 1000 by 10, 100 is also 10. So here the common ratio is 10. In the first case we did, the common ratio was minus 6. Okay, we'll take one more. Okay, so let us take 2, 8, 32, 128. Is this a sequence? Is this a sequence? Yes. Is it AP? No. Is it GP? Yes, because 8 by 2 gives me 4, 32 by 2 is 4, 128 by 32 is also 4. So the common ratio is 4. So it is a GP, GP, GP. The next one, 1, minus 1, 1, minus 1, 1, and so on. Is it a sequence? 1, minus 1, 1, minus 1, 1, minus 1 like this. Well, it is a sequence because even though it does not increase, but it changes sign and you can predict. So again, you see, this is of that type where it once goes to the plus side, minus side, plus side, minus side, plus side, minus side, plus side, minus side. And this, if I draw this curve like this, you know, this is called the amplitude. Okay. This is 0, 0, and this is 1. So once it reaches plus 1, then again it comes down. This is minus 1. Again it comes to 0, again it goes to plus 1. So this is a sine curve. It is like the wave. Okay, wave. Ocean waves. Okay. Sometimes it's going down, up. Okay. So what goes up must come down. So it's going up, coming down. Again going up, coming down. Okay. So this is also a sequence. And you can see this 0 to the extreme. Base to the trough. Trough is the extreme. So this, if you see, apex, right? So this is called the amplitude. Amplitude is same. Once it is going up, 1 unit, again it goes down, minus 1. So up, down, like that. So this is also a sequence. And can you find out the common ratio? This is a sequence. Is it an AP? No. Let us see the common ratio. This by this. Minus 1 by 1 is minus 1. Again, 1 by minus 1. 1 by minus 1 is equal to minus 1. Okay. So therefore, here, this is also GP and the common ratio is minus 1. Okay. Now let us take another one. So I'm just rubbing this part. Common ratio is minus 1. You could understand, I hope. And I'm also trying to define and show you how the curve will be. Okay. Sometimes the curve is like this. Amplitude increasing. Like this. Increasing. Sometimes it will be constant. Plus 1, minus 1. It will just change. This is the phase. It will just change. Sometimes it goes up, it comes down. Up, down, like this. This. Okay. Now, last one. 20, 16, 12, 8, 4. 20, 16, 12, 8, 4. Is this a GP? Is this a sequence? Yes. It has a steady decreasing trend. Is it a GP? No. This is not a GP. So therefore, it's, in fact, you can see here we have something called common difference. Not common ratio, but common difference, because 16 minus 20 is minus 4. 12 minus 16 is minus 4. 8 minus 12 is minus 4. 4 minus 8 is minus 4. So this particular, the last one which I have taken, this is nothing but an AP, an arithmetic progression, and the common difference is minus 4. Okay. So the first one is a GP with common ratio minus 6. The second is a GP with common ratio 10. The third is also a GP with common ratio 4. The next one is also a GP with common ratio minus 1. But the last one is not a GP, it is an AP with a common difference of minus 4. Right. Some more examples quickly. I hope you are getting the idea of GP. Since you know AP, GP will become easy to understand. Okay. Let us take one more example. Request you to keep note. And you can write with me. Okay. I am taking this minus 6, 18, minus 54, and so on. Then the next one I'll take is 5, 15, 45, 135. And I'll also take 1. Let's take half. Then let's take 1/4. Okay. And so on. Okay. 1/8. So on. So we shall try to see whether these are AP or GP. The first one, minus 6, 18, minus 54. Okay, the first one, minus 6, 18, minus 54. Is this a sequence? Yes. Because there is a sign change and it is increasing. Fine. There is an order, there is a trend, there is some pattern. Fine. Is this AP? No. Is this a GP? Yes. Because we have a common ratio. Now, how much is the common ratio? 18 by minus 6 gives you minus 3. Minus 54 by 18 also gives you minus 3. So it's a GP with a common ratio minus 3. Done. Second one, 5, 15, 45, 135. You can see it increases, right? 5 into what gives you 15? 3. So 5 into 3 is 15. 15 into 3 is 45. So if you divide, 45 by 15 is 3. 135 by 45 is also 3. So here it is a GP. No doubt it's a sequence. It is a sequence. It is a GP. And here the common ratio is 3. The last one, 1, then half, then 1/4, then 1 by 8. Decreasing trend from 1 to half, then 1/4, then 1/8, becoming from big to small, small. So here the common ratio, if you see the common ratio CR, in this particular case the common ratio is half. Okay, since it is half, you can understand this also is a GP. The third one is also a GP with a common ratio half. So all the three expressions which you see here, the sequences which you see here are GPs, geometric progression, and I have also computed the common ratio for each of them, right? Now let's move on and see some more examples. Okay, before that it's time for the formula, right? We need to remember the formula now. Okay, so just as I have written the formula here for AP because it's easy for you to relate, right? Now AP we did the nth term, so in GP let us do the nth term. The nth term in a GP, but in case of GP please remember we have term 1. The first term is A, like we have in AP also, but we don't have a common difference. We don't have a common difference. So the D which you say here in case of AP, but in case of GP it will become common ratio, and common ratio is denoted by R, right? R. So we have a common ratio R. Now let us see what will be the nth term in a GP. The formula is Tn is equal to A into R to the power n minus 1. So you have to remember this formula, and I will be writing this here. So for AP and GP you need to remember almost 8 to 10 formula. 6th formula we have already seen for AP, and the remainder is for GP. So this is a very, very important expression which you need to remember. Tn is equal to AR n minus 1. AR R to the power n minus 1, of course. So let us take an example. Okay, let's take an example and solve it. Remember that the more formula we learn, right, and the more numericals we do, the easier it becomes, and we get more comfort in using that formula. So let's take an example. I am giving you a progression 1, 2, 4, 8, and in this way it goes on, and there is a term 256 in this progression. The number 256 comes in the progression. You have to find out which term is 256. So it starts with 1. The first term A is 1. 1, 2, 4, 8. It goes on, and then there is a term 256. You have to find out which term in this geometric progression will be 256. You can see it's a GP because the numbers are increasing, and you can see 2 by 1 is 2, 8 by 4 is 2. So the common ratio is 2. So here A is equal to 1. R, that is common ratio, is equal to 2. So we have to find out 256. Which term? So we put the formula AR n minus 1. So the formula here is A is 1 into R is 2. 2 to the power n minus 1. This is equal to 256. 256. Now if you solve 256, if you see, you will find that 2 into 2 is 4, into 2 is 8, into 2 is 16, right? Into 2 is 32, into 2 is 64, into 2 is 128, into 2 is 256. Okay, right. So you will see that 2 to the power 8. That means 2 to the power n minus 1 is equal to 2 to the power 8. That is, since the base is same, we have n minus 1 equal to 8, or n is equal to 9. So the ninth term in this GP, the ninth term will be 256. So these type of problems often come in the exam, and of course this is one of the easiest, since we have just gone ahead with GP. I am first taking the easier examples. So here n is 9, and we are using the formula AR to the power n minus 1. Fine. I am sure you are conversant with A is the first term, and in case of GP, we do not have common difference. We have common ratio denoted by the letter R. Okay. Next one is, I'll just rub this up. I hope you have the formula in mind, or I'll write it. Okay, let me write it here. So here we have the AP. I'll just make a small box here and write formula number 7, that is GP, and the first formula is Tn equal to AR to the power n minus 1. Okay, I'll keep it like this. So we have the formulae for arithmetic progression Tn, sum, for the even numbers, for the odd numbers, for the squares, for the cubes, and then for the GP. Okay, this box is for the GP. Okay, now let us take the other example. I have in front of me another example, 7, 21, 63, and so on. 7, 21, 63, and so on. You have to find in this series the ninth term. You have to find the ninth term. Okay, the ninth term in the series 7, 21, 63. So here, of course, we have, let us see, what do we have? We have A equal to 7. Fine. The first term A is 7. Is it a GP? Yes, because 21 to 7 is 3, and 63 divided by 21 is also 3. So the common ratio is 3, and the common ratio is constant. Okay, so it's a GP. Okay, and therefore the ninth term will be given by what? You know the formula is AR to the power n minus 1. So A into R to the power 9 minus 1, because you have to find the ninth term. So 9 minus 1. A is 7, so I write 7 into R is 3. So 3 to the power 9 minus 1 is 8. So 7 into 3 to the power 8. You have to just calculate. Sometimes in the exam, some of you are asking, sir, do we need to find out exactly what this number is going to be? Well, it depends on the options given. If you see in the options A, B, C, D, if you see that the options are like this, say, I'll write it like this, say the options given are, number 1 is, say, 6 into 3 to the power 7. Option B is given 7 into 3 to the power 8. Option C is 6 into 3 to the power 10. And option D is 7 into 3 to the power 12. So here, no need to calculate, because you know the options are like given in this way. So you can easily see option B is the correct answer. Okay, option B matches with your answer, so option B is the right answer. In this case, no need to calculate, no need to compute. So be very careful once you arrive at these type of expressions where you have 3 to the power 8, 3 to the power 20. First see the options. It may so happen that you don't have to calculate. Looking at the options, you can match which option is correct. Okay, so I'm just rubbing this part. So this is the answer, 7 into 3 to the power 8. Right. I go to the next one, and I hope you can see that this is not such a difficult chapter, but I'm sure you are happy because this is a scoring chapter. Right? AP and GP will be a scoring chapter. I told you on the first day, this chapter is based on formula, but permutation combination is based on thinking plus formula. I think if I am a student appearing for the exam, I'll pay more attention to permutation combinations, because there I have to think also. Whether it's a permutation or combination, you have to find out. I will give more attention to time value of money also, because there, whether to use annuity due or annuity regular, Whether it's a case of present value or future value, I have to think and bring out. But here in AP and GP, you won't have any problem, because looking at the question itself, you will quickly understand. In the flash of a second, you will understand, oh, this is an AP. I have a common difference here, so AP. Oh, in this problem, I have a common ratio. Oh, then it's a GP. Okay, it's easier to understand. Okay, let me take the next one. And the problem is like this. You have to find out the seventh term. The seventh term of the series half plus 1 by 4 plus 1 by 8 plus so on. Okay. You have to find the seventh term. Okay. Now, what will be the seventh term here? Again, a r n minus 1. So here a is equal to half. You can see what is r equal to? Common ratio. Common ratio, if you take this by this. So 1 by 8 divided by 1 by 4. That means 1 by 8 into 4. So it gives me half. Okay. So a, the first term is half. The common ratio is also half. So I have to find out the seventh term. So it is half multiplied by half to the power 7 minus 1. That is half into half to the power 6. But you know, half into half to the power 6 gives you what? It is half to the power 7. 6 plus 1. Okay? Or you can put it in this way. Half to the power 7. 1 by 2 to the power 7 is what? This is equal to 2 to the power minus 7. 1 by 2 to the power 7 is equal to 2 to the power minus 7. So 2 to the power minus 7 will be the answer. You can expand. Right. Okay. Now we come to the next formula and the last formula, of course. No, not last. Two more formula. Right. Okay. So there's one more formula, of course. So let me take this one. Okay. Easy one. Easy one in the sense calculation might be long to do, but concept is easy. The sequence is 1 minus 6, 36 minus 216. You have to find out the 10th term. 10th term in the series. So T10. T10 will be equal to what? A into R to the power 10 minus 1. Here the first term is 1. Because it starts with 1. 1 minus 6, 36 minus 216. And so on. So the first term is 1. So term 1, A equal to 1. Also, the common ratio is, if you see, minus 6 by 1 gives you minus 6. So the common ratio R is equal to minus 6. Right? Therefore, the formula, if you apply A, R, N minus 1, then it becomes nothing but 1 into minus 6 to the power 10 minus 1, that is 9. Okay? So this will be the answer. That is 1 into this is minus 6 to the power 9. Okay. So this is the answer to this question. Now we go to what is the second relation, and that is geometric mean. Geometric mean. Okay. So if I tell you that, you remember arithmetic mean. So if I say that X, Y and Z are in AP. If I say so that X, Y and Z are in AP. Okay. They are in AP, not GP. It is AP. Okay. Arithmetic progression, not GP. So from this we easily know that Y will be the arithmetic mean of X and Z. In other words, Y will be equal to X plus Z by 2. X plus Z by 2. Okay, so we have the concept of half. Half of X plus Z. So I can write like this. This is nothing but half of X plus Z. Okay, I hope it makes sense. This is what we call arithmetic mean. Okay, where you have half of X plus Z. The middle term is the 50%, half of X and Z. So I am the middle term. I will be half of the term before me and the term after me. Okay, this is arithmetic mean. Please remember. Okay. Now for geometric mean, what will happen? If I say that X, Y and Z are now not in AP but in GP, then please remember, then what happens? What is the relation? The relation will be Y by X will be equal to Z by Y. Okay. Y by X, this is the middle term divided by the preceding term. Okay, so let's call it term 1, 2 and 3. Second term by first term. Y by X is what? Second term by first term. Okay, second term by first term is equal to third term by second term. And that is common ratio. So if you have this equation, then what do you get? You get, if you cross multiply, you get y square equal to x into z, which means y is equal to plus minus square root of x into z. So please note this relation. This is the concept of geometric mean. Okay? So if A, B, C are in GP, here we are taking if X, Y, Z are in GP, in geometric progression, automatically we get the relation, and here Y is known as the geometric mean. Y is the geometric mean of X and Z. So please note, this is the difference between arithmetic mean and geometric mean. In case of GP, we don't use AM, but we use the term GM, geometric mean. So the middle term is nothing but the square root of the two extreme terms. Right? I hope this is absolutely clear. No worries, no questions. We move on. Y equal to plus minus square root of X and Z. Let's proceed on and let's go into some examples of GM, geometric mean. We will take some questions here which came in the exams. Right. Of course, I will write the formula of geometric mean in the box. I'm writing down all the formulas. I'm sure this is going to help you so that you can note all the formulas important for this chapter. And here I'm writing number 8, geometric mean is equal to square root of term 1 and term 3. Okay, that is term 1 into term 3 in fact. Okay. Now we shall take up a question. We have to insert 3 geometric mean between 1 by 9 and 9. So you have 1 by 9 and you have 9 here, and you have to insert 3 geometric mean. So it will be 1 here, 2 here and 3 here. 3 geometric mean will be there between 1 by 9 and 9. You have to insert them. How do you do? Okay. So if you look at this given relation, first you please see that it is given it's a GP. The question tells you that geometric mean means it is a GP. No doubt about it, no hesitation about it. It is a GP. Now, this is the first term. Okay. So term 1 is T1 is this. Okay. T1. Second, third, fourth, and this is fifth. So this is the fifth, T5. This is T1. Please see the steps. Please note the problem so that you have no problem, no difficulty in understanding. Simple question, 1 by 9 and 9. In between them, you have to insert 3 geometric means. Okay, so how do we do it? So we have brought 3 circles here, indicating 3 GMs, 3 geometric means. Now the question is, first term is 1 by 9. Okay, so the first term is 1 by 9. So I write A equal to 1 by 9. And we know that second, third, fourth and fifth term is 9. So term number 5 equal to 9. If the common ratio is R, let us take the common ratio as R. Fine. The common ratio I am taking as R. This formula, AR to the power n minus 1. So I can write the fifth term is nothing but A into R into 5 minus 1, that is 4. Okay? A into R into 5 minus 1, that is 4, because here R is, we don't know, and n is 5. So AR n minus 1, n minus 1, n is 5. So n minus 1 is 4. So AR to the power 4, this is equal to 9. We know the value of A here. A is 1 by 9. So I put 1 by 9 into R to the power 4 is equal to 9. Okay? So this means R to the power 4, if you see, comes to what? Comes to 81. 9 into 9. R to the power 4 comes to 81. Which means R comes to 9 into 9 is what? 3 square into 3 square. Okay? So it is 3 to the power 4. R to the power 4. R to the power 4 equal to 3 to the power 4. So R is equal to 3. So we get R equal to 3. R is 3. So the common ratio in this example is 3. Now, we know A. A is 1 by 9. We know the common ratio. So we can easily find out this term. Okay? How do we do it? Just by multiplying. The first term into common ratio gives you the second term. Second term multiplied by common ratio gives you the third term. And so on. Okay? I hope it's clear. Right? So, 1 by 9 into 3. 1 by 9 into 3 is how much? 1 by 9 into 3 is 1 by 3. So, 1 by 3 is the next term and the first geometric mean is 1 by 3. Okay? So, I now just rub this and I put 1 by 3 here. The first geometric mean is 1 by 3. Now comes, so we have got second term. First term, second term. We know the second term is 1 by 3. We know the common ratio is how much? Is 3. So what is the third term? It will be 1 by 3 into 3. That is 1. So I write 1 here. So we have got 1 by 9. Then we have got 1 by 3. Then we have got 1. Okay? Now, so we wanted to insert 3 GMs. 3 geometric means. We have already got first and the second. What will be the third? So this term is how much? 1 into 3, because 3 is the common ratio. So 1 multiplied by 3, that is how much? 3. So this 3 is the common ratio, and therefore the 3 geometric mean will be 1 by 3, 1 and 3. So the answer is this. 1 by 3, 1 and 3. This will give you the 3 geometric means. I am sure it's clear now, and that is how we formulate and develop a way to solve these type of numericals. If they tell you that instead of 3 geometric means, if they tell you 5 geometric means, then what will happen? Then the first term remains 1 by 9, 5 geometric means will be here. So 1 and 5 is 6. So this 9 will be the 7th term. Accordingly, you put n equal to 7 here and solve for r. Right? So this is how we solve these type of problems. Right, next one. Very easy. I have taken a difficult one first. Now I'll take an easy one so that it becomes cakewalk for you. Very easy problem now. You will be completing it in a few seconds, maybe nanoseconds, some of you. Okay. You have to insert one geometric mean between 1/4 and 4. Insert one geometric mean between 1/4 and 4. So, we know that if the geometric mean is, say, x, so x will be in between this. So, the formula will be what? You remember we wrote for x, y, z. If y is in between, then we remember y square equal to xz. So here it will be what? It will be x square is equal to 1/4 first term into last term. Okay? So 1/4 in between 1/4 and 4th, it will be +1 or -1. We have to consider both the numbers, both the plus and the minus sign, both sides. Okay. So this was an easy one, and I hope you are now clear. We shall proceed to the last formula. Probably the last one. I'll call it the last one because there's one more small formula that I won't even call an additional formula. It's easy, but let's see the last one. So we have seen already the nth term, and we have seen what is the formula of the geometric mean. Now we see what will be the case like arithmetic progression, the sum of a series, geometric series. So it is given 3 plus 6 plus 12 plus 24 plus so on. What will be the sum of the series? So number 9, the formula is Sn, it will be equal to, please note, a r to the power n minus 1 by r minus 1. Okay? Please note where r is greater than 1. If r is greater than 1, that means if the common ratio is greater than 1, then please use this formula, a into r to the power n minus 1 by r minus 1. Okay, a into r to the power n minus 1 divided by r minus 1, provided r is greater than 1. If r is less than 1, okay, so I am writing the formula. If r is less than 1, then the formula will be just inverted. So then the sum will be a, instead of r to the power n, it will become 1 minus r to the power n. In the denominator, instead of r minus 1, it will be 1 minus r. Okay, so I am writing the formula here. The sum will be a into r to the power n minus 1 by r minus 1. Provided r is more than 1. If r is less than 1, as we can see, if the value of r, say r is 1/4. Okay, r is minus 3. In that case, r is less than 1. So we will use this formula. A into 1 minus r to the power n divided by 1 minus r. Right? So let us note these two formulas. So now we have 9 formula in all. So we have, for AP, we have the nth term, we have the sum, we have even numbers, we have for the odd numbers, we have the squares, we have the cubes. Then we saw the GP formula number 1, the formula for the nth term of a GP. Then we saw the formula for the geometric mean. And finally, we see the formula for the sum of a GP series. Okay, here I am using the term series. Please note series and not sequence, because sum of a series means 1 plus 3 plus 5 and like that. Or if it could be for a GP, for example, say 5 plus 10 plus 20 plus 40 like this. If it goes, then it becomes a GP series. So we use the word series and it is no longer a sequence. Okay. So let us take an example and let's solve this. I hope you are following, and it's not that difficult as many of you may have thought earlier. Okay, so let's take this example. I'm rubbing this and we'll use the formula. The formula is written here for ready reference. I'm jotting down all the formula from arithmetic mean as well as from arithmetic progression as well as geometric progression, so that it becomes easy for you. Now, you have to find out the sum of the first 20 terms. I am writing the progression like this: 2 minus 6 plus 18 minus 54 plus, like this, it goes on. You have to find out the sum, okay, the sum of the first 20 terms, that is S20. Okay, let's look at the problem. Okay, Step number 1. Is it a sequence? Quickly, let's recap. Yes, it is a sequence. Why? It increases and it changes sign like this. Minus plus, minus plus, minus plus, alternating. Right? I told you in case of AC, alternating current, the curve is also like this. You know there are two sources of power, AC and DC. Alternating current and direct current. Okay? So if you look at the curve of an AC, okay, you will find it's like this. Right? So it will be like this. Here also you can see is a baseline like this. Positive range, negative range. Positive range, negative range. Okay? It is called a sinusoidal wave or a sine wave. It's like a waveform. Same thing here. So you can see it is a sequence because it obeys certain rules, certain laws, it increases and it changes sign alternatively. Minus plus and so on. Is it an AP? No. Is it a GP? Yes. If it is a GP, what is the common ratio? Common ratio will be take this term by this term. So let's take CR, common ratio is equal to say minus 6 by 2. Minus 6 by 2 gives me minus 13. You take this one, 18 by minus 6. So 18 by minus 6, also minus 3. So I know the common ratio, that is R is equal to minus 3. Fine. I know the first term is 2. So I can write, I can write A equal to 2 and R equal to minus 3. And we have to find out S20. Very good. So N is equal to 20. So what is the sum? The sum is given by this formula. A to the power R, A into R to the power N minus 1 by R minus 1. Now here the common ratio is minus 3. Please note. And minus 3 is less than 1. So we shall use which formula? Shall I use this formula? No. I will use the other formula. S20 will be A is 2. So I write 2 here. And then I write 1 minus. So 2 I am writing here. 1 minus. The formula was Sn equal to A into 1 minus R to the power N by 1 minus R. So here S20 is A is 2. 1 minus R to the power N. R is minus 3. So 1 minus 3 to the power 20 divided by 1 minus R. That is 1 minus 3. Okay. So please see this A. 1 minus Rn, R to the power N. This R is minus 3. R to the power N, here it is minus 3 to the power 20. 1 minus R, R is minus 3. So if you simplify this, you can just simplify one step, no need to calculate 3 into 3 into 3 into 3 up to 20, times. If you simplify this, what do you get? If you simplify this, you are getting, final answer will be 2, okay, the final answer is 2, 1 minus 30 to the power 20 divided by 1 minus 3 is 4. So cancelling, the final answer is 1 minus 3 to the power 20 by 2. So here we use the formula A into 1 minus R to the power N by 1 minus R. Why? Why have we used this formula? Because we have seen that here the common ratio is working out. We have worked out the common ratio and the common ratio is minus 3. And as per our formula, if the common ratio is less than 1, then we shall use the other formula. If R, that is common ratio, is more than 1, then we shall use this formula. Otherwise, we shall use the reverse, that is A into 1 minus R to the power N by 1 minus R. We shall use this formula. Okay, now the last small trouble for you. You have to note down, this is the 9th formula, the last one. Let's make it a round figure, 10th formula. 10th and the last one. Now, friends, we discussed in the last class, you remember, on time value of money. Now, I discussed about perpetuity and then I said that it was a geometric series. You may remember I said that. In fact, you remember when we were discussing perpetuity, we had done this case, right, where we had R is the return, I minus G. Okay, it was the present value, right, the value of a growing perpetuity, right, where R was the return and I was the interest rate and G is nothing but the growth rate. And I said that this was an infinite GP series. It was an infinite geometric series. So in this case also, if you have a question like this, that there is a case of an infinite GP series which never ends. Now in the last problem we found out the sum of the first 20 terms. But if there's a question like this, that, let's take an example of, well, say a question is like this. Okay, looks a bit clumsy, but I'm sure you'll understand. Sigma n is equal to 0 to infinity. Okay, 0 to infinity, and 4 into 0.6 to the power n. How do you deal with this? Okay, please see the formula. Sigma n equal to 0 to the power infinity, 4 into 0.6 to the power n. So how do you deal with this? If you expand this, what you get is 4 plus 4 into 0.6 plus 4 into 0.6 square. Like this, it goes on and on and on. It's infinite GP, because please note n is 0 to infinity. Infinity, as I understand, this concept is going to be very useful for you. Okay, when we discuss about differential calculus, integral calculus, and you will see the beauty of mathematics. Forget about scoring good marks. You will definitely score good marks. But the idea in becoming a professional is not just to do well in a subject just for the sake of marks. Accounts, economics, are you studying that only for the sake of marks? No, it has to be for a lifetime, because whatever you are learning, you are creating the base in CA Foundation. If the foundation is strong, the building will be strong. Think of the great pyramids of Egypt. The great pyramids of Egypt were built on a solid foundation. That is why even after 5,000 years, the structure is the same. So a foundation is important. That's why the exam is also CA Foundation. Right? So you are creating the basis. In this case, whatever concept you learn today during these classes will become part of your hard disk. It will go into your software. It will be part of your memory. And you will use this knowledge not only for getting good marks in foundation, but also to fall in love with the subject. Accounts should be slowly, it should become part of your DNA. Mathematics should become part of your DNA. Right? Law, economics, BCK, business commercial knowledge. Because when you become a chartered accountant in the years to come, you will be applying all these. So, infinity. When you talk of infinity, infinity is not a number. It goes on and on. If you later on study, I don't know how many of you have studied the theory of relativity, which was developed by Albert Einstein, the well-known physicist. Right? Very well known, and he was a Nobel laureate. He was born in 1879 and passed away in 1955, and known as one of the most revolutionary, physics expert, mathematician, and physics expert in physics the world has ever seen. Now, according to him, infinity is only a symbol. It is not a number. You cannot, when we talk of, infinity goes on and on in future. You cannot stop. Think of the solar system. Think of the Milky Way. Think of the universe. It is expanding. No limit. Similarly, here it is an infinite. Zero, it goes on and on. But through mathematics, it's an infinite GP series, and there is a formula for infinite GP series, and the formula is very simple, which I'm writing here: A into A divided by 1 minus R. That means the value of an infinite GP series will be A divided by 1 minus R. This will be the sum. So in this case, if you have finite, one of my friend asked me in the last class in the question, so what is finite? Finite means countable. Like we were talking about series, right? Sequence and series. Series means like what we are doing here, plus. But in this case, series are of two types, finite series and infinite series. This is an example of infinite. Infinite means uncountable. Finite means you can count it. Even if you cannot count it physically, manually you can do it through a machine. But infinite, no, infinity goes on and on. Okay? So therefore, it's a beautiful idea. If you ever see mathematics and physics, normally they come together, they crisscross each other, especially when you talk about infinity. Okay? And this is an example of an infinite GP series, but fortunately, the idea may seem to be, very difficult. To imagine what is infinity is difficult. It's difficult to imagine. But the formula, by God's grace, the formula, and for all of us, formula is so simple. A by 1 minus R. Okay, so in this case, A is the first term 4. So the value will be 4 divided by A divided by 1 minus R. 1 minus R. R you can see is 0.6. So it is 4 divided by 1 minus 0.6. This becomes 4 divided by 0.4. So it becomes, I think, 10. Okay. So this becomes 10. So this is the value of this infinite GP series. So we have completed all the formula necessary for understanding the geometric progression. And now we will do some more revisions quickly. Okay. So I'll rub this part. Good that we could do this problem. And I could explain a little bit about what is infinity, and this I will again explain next day when we take up differential calculus and I talk about limit, continuity, and the concept of differentiating, right? ddx, right? Fine. Let's go to the next one. Okay, so this is a classic one. 6 plus 27, please write 6 plus 27 plus 128 plus 128 plus 629 and so on. Okay, I'll rub this part. You just note this formula. I'll just rub this part. I may use it for writing. Okay, instead I'll write formula number 10 here below. S is equal to A by 1 minus R. I'll write here. I think it is visible. This is only a ready reckoner. This part of the whiteboard I have kept only for ready reckoner so that we can easily refer to any of the formula while calculating while working on any problem. We can quickly relate, interlink. Okay. Okay. So here let's do this problem. 6 plus 27 plus 128 plus 629. Little bit of brain work is important. Little bit of, I request you to accept this challenge. Okay, challenge with me, and together let's challenge the problem. Is this? How do you? If this question comes in the exam, how do you find the sum? Okay, this is, however, from the study material. Please refer to exam page number 6.12. Page 6.12, and this is example number 2. Okay. 6.12, example number 2. See the problem first. Now if you break it, you will get, very carefully I am saying, 6 can be broken into 5 plus 1, plus 27 can be broken down into 25 plus 2, and 25 can be broken down into 5 square. I can write 5 square for 25, so it is 5 square plus 2. 128 if you see is how much? 128 means 125 plus 3. But 125 is what? 5 into 5 into 5. So 5 cube plus 3. So the third expression is 5 cube plus 3. Then you have 629. 629 is nothing but 625 plus 4, and 625 is 5 into 5 into 5 into 5. That is 4 times. So 5 to the power 4. So this is 5 to the power 4 plus 3. So if you break this up, wonderful problem, one of the best problems, If you break this up, it becomes a GP as well as an AP. So how it becomes a GP? Now if I take this one, 5 plus 5 square plus 5 cube plus 5 to the power 4. This becomes the GP portion. Plus I take 1 plus I take 2 here. I take 3 from here. I take 4, this will be 4. I take 4 from here and go on. So please note this portion and so on gives the GP part, and this portion is the AP. Right? I hope you are able to break it down. Now, dear friends, 5 plus 5 square plus 5 cube plus 5 to the power 4. So, here the first term A equal to 5. Right? So, I write A is equal to 5 and R is also equal to 5. So, this sum will be, we will use this formula. Here R is 5. That means R is more than 1. R is greater than 1. So we shall use this formula Sn equal to A to the power R to the power n minus 1. A into R to the power n minus 1 by R minus 1. So this portion will be 5, that is A, into R. So here we are actually finding out what? We are finding out till n terms. Okay, here it's n terms. So 5 is the R value is 5. So 5 to the power n minus 1 divided by 5 minus 1. So this is the part of GP, sum of the GP terms. Plus we have the AP. 1 plus 2 plus 3 up to n. So up to n. The formula is written here. 1 plus 2 plus 3 plus 4. This is basically, we write n into n plus 1 by 2. Okay, the formula is n into n plus 1 by 2. So, what I do is, we write n into n plus 1 by 2. So, the formula is n into n plus 1 by 2. So, this will be the final formula, the final expression. That is 5 by 4, because 5 minus 1 is 4. 5 by 4 into 5 to the power n minus 1 plus n into n plus 1 by 2. Okay? Right. Now we move on to, let's take, okay, page 6.16, let's take, let me take this one. Okay. Let me take the questions. Exercise 6B, number 4. Okay, I'll take the questions. I rub this part out. Okay. So let's go to the questions. The formula are all written for your ready reference and for me to, in case if I forget, so many formulas, very difficult to remember. If I forget, I can quickly check. Okay? Right, fine. So let me take 6B number 4. So we are focusing on exercise 6B and the question number we are taking is 4 first. The fourth term of the series is given. Please open the question 0.04. Then we have 0.2, then we have 1. Okay. And so on. What is the fourth term? Okay, the fourth term. So we use this formula. AR n minus 1. AR to the power n minus 1. So here you can see it starts with 0.04. So A equal to 0.04. R is term 2 by term 1. So 0.2 by 0.04. And I think this gives me 0.2 by 0.04 gives me 5. So R is 5. We have to find out the fourth term. So T4. This is equal to A into R into 4 minus 1. A is 0.04 into R is 5 to the power 4 minus 1. And 4 minus 1 is 3. 5 to the power 3. 5 to the power 3 is how much? 5 into 5 into 5. So 125. Okay. So this is equal to 0.04 into 125. So 125 into 4, 20, 4 5 is 20, 0, 2, 4 2 is 9, 10, 4 500, and you have this. So it comes to 5. Answer is 5. Okay, the answer to this question is 5. So we have used the simple formula a into r to the power n minus 1. Right. Let's take this one. Number 11, 6b. We are doing 6b. Fine. Number 11. So 4 I am rubbing out. I hope this is easy now. All the formula I have written for your quick reference so that you have no problem. And we are now comfortably taking up number 11. Right? So let us try number 11 of 6b. Exercise 6b, number 11. The second term of a GP, is 24 and the fifth term is 81. Okay, so the second term T2 equal to how much? 24, and T5, the fifth term is 81. Very good. What is the series? You have to find out the series. Exercise 6b, number 11. Okay, so second term means using this formula. So, second term means a into r to the power 2 minus 1. That is a into r. So, a into r is 24. Fine. Very good. Excellent. Now we take the fifth term. Term 5 is equal to a into r to the power 5 minus 1. So, this is a r to the power 4. This is equal to 81. Great. So, we have AR is 24 and AR to the power 4 is 81. So, if you divide 2 by 1, so equation 2 divided by equation 1, I hope you are following, dear students, right? I think no problem so far. 2 by 1 gives me AR to the power 4 by AR, and this is equal to 81 by 24. 81 by 24. So we cancel A. So this becomes R to the power 4 by R, which is nothing but R cube. This is equal to 81 by 24. 81 by 24. Okay. So, what is R? So if I think this will, we can cancel by 3. So 3 8s are 24 and 27. 27 by 8. Now 27 is 3 into 3 into 3. That is 3 cube. And 8 is 2 into 2 into 2. 2 cube. So R is equal to 3 by 2. So we have got R. We know A. A is, I think it is, I have to now find out. Yes, AR is 81. Okay. AR is 24. Sorry. AR is 24. And R we have got is 3 by 2. R is 3 by 2. So, A into 3 by 2 is 24. That means 3A is equal to 48. So, A is equal to 16. So, we have got A equal to 16 and we have got R is equal to 3 by 2. Okay. So, what is the series? The series will be 16 first, then 16 into 3 by 2. That is 2 is 24. Then 24 into 3 by 2. That is 36. And so on. So the answer is 16, 24, 36 and so on. Right? I think this is clear now. This was number 11. Fine. Now we take up number 13. I am taking as many problems as possible. We take up number 13 now, rubbing this part. Formula as usual is written for you. No problem. We are taking number 13 of exercise 6b. Number 13. Well, let's see the problem. In a GP, the product of the first 3 terms is 27 by 8. So in a GP, the product of the first, so T1 into T2 into T3 equal to 27 by 8. You have to find out what is the middle term. So you have to find out this one. So it is taking some time, but otherwise in the exam, under tight exam conditions, you should be taking around 30 seconds to 40 seconds to complete this, right? So we can easily understand looking at the problem. three terms of a GP. So let the terms be A by R, A and AR. Okay? You can see the common ratio is R because A by R into R gives you A and A into R gives you AR. So here the common ratio I have taken is R. So no question about it. Now you have to find out the product. The product is given 27 by 8. So I take A by R into A into AR equal to 27 by 8. So here R cancels with R. I have A into A. That is A cube equal to 27 by 8. Okay, A cube. But the question is 27 by 8. A cube is coming to 27 by 8. But 27 by 8 is nothing but 3 by 2 cube. 3 into 3 into 3 is 27. 2 into 2 into 2 is 8. Right? I hope you are following. Okay. So A cube is 3 by 2 into 3 by 2 to the power cube. Therefore, A is equal to 3 by 2. So A is the middle term. Please see, as per our assumption, A is the middle term. So the answer is, the middle term is 3 by 2. One line problem. Okay. Just assume the numbers in an intelligent way. You are becoming a CA. You are becoming a professional. Not by mugging up. Okay. A person who mugs up, memorize and commit and vomit in the exam will not go very far. Maybe foundation clear, inter one group clear, then finish. End of the game. But if you are an intelligent person, you study, you also apply your intelligence, then you will go far. Here, if I say that no, let me take, if I take the numbers as A, AR and AR square, I won't be able to solve it. I have taken A by R, A and AR, so that I can get R and R cancel out. Okay, that's how I did it. Fine. So please remember this. This was number 13. Now let us take number 20. Okay, let's take number 20. Go to 20. Exercise 6B we are proceeding with, and we take number 20. Please open number 20. The question is, the sum of the series 1 plus 2 plus 4 plus 8 up to n is how much? So 1 plus 2 plus 4 plus 8 up to n is how much? Okay, fine. Options are given, of course. Now, if you see here, the term 1, that is A equal to 1. It starts with 1. Okay, it starts with 1. What is the common ratio? 8 by 4 is 2, 4 by 2 is 2. So it's a series. You can see it's a series, not a sequence, series. Because there is a sum. So here R is equal to 2. Very good. So we have to find out the sum of the series. And here R is 2, which means it is greater than 1. So we shall use this formula. Okay. A into R to the power n minus 1 divided by R minus 1. So let us put these values here and see what happens. Okay. So we put the value here. So instead of A, I will put 1. And for R, I will write 2 to the power n minus 1 by R minus 1. R is 2. So 2 minus 1. So this gives me the answer 2 to the power n minus 1. 2 minus 1 is 1. So the answer is 2 to the power n minus 1. Okay, this is the answer. So you have seen summation formula. Sum is A into R to the power n minus 1 by R minus 1. Full expression is given. A is given. R we have found out. Okay, R is 2 in this case. So directly by putting the values of A and R in the given formula, we derive the value as 2 to the power n minus 1. Okay, so this was number 20. Now let us take, let's take number 6, exercise 6C now. Let's move to exercise 6C. Fine. So we are now proceeding to exercise number 6C. So it is exercise 6C. and the first the problem we'll be taking is number 4. Let us take number 4. Okay, the sum of the first two terms of a GP is 5 by 3. Fine. The sum of the first two terms. Okay. Okay. And the sum to infinity of the series is 3. Fine. So let the sum of the first two terms, so let the terms be A and AR. Okay. So common ratio is R. First two terms. So the sum is given, A plus AR is equal to how much? Let's take, it is 5 by 3, it is given. Please see the problem. Problem number 4, exercise 6C. Okay, so A plus AR is 5 by 3, this is given. Sum to infinity of the series is also given. Sum to infinity is the formula A divided by 1 minus R. So sum to infinity, I am writing infinity symbol. This is equal to A by 1 minus R, and here A is, I have taken A, fine, 1 minus R, and this is equal to 3. Okay, so we have got two equations. A plus AR equal to 5 by 3, this is equation number 1, and A by 1 minus R equal to 3, this is equation number 2. Okay, so we are getting first equation and we are getting the second equation. Okay, so let us see how best we can break it up. So let us work out and see. So we have, from the first equation, we have, if you take A common, you get 1 plus R equal to 5 by 3. And from this equation, you will be getting A equal to 3 into 1 minus R. Okay. So from the first equation you are getting A equal to 5 by 3 into 1 plus R. 1 plus R comes down. And from here you are getting A equal to 3 into 1 minus R. So let us equate these two. So we are getting two values of A. First is 5 by 3 into 1 plus R. And the second you are getting is A 3, 1 minus R. Okay, so let's equate and see what happens. Okay, so I'll just rub the upper part here because this part is done. I'll just solve it here. We have got the formula, two formulas. We have got two results. We have got, let's solve it up. So we have got A equal to 5 by 3 into 1 plus R. So 5 by 3 into 1 plus R. This is equal to 3 into 1 minus R. 3 into 1 minus R. Let's check. Okay. So by cross multiplying, you are getting 9. 3 3s are 9 into 1 minus R squared. This is equal to 5. Which means, if you expand, 9 minus 9R squared equal to 5. Which gives you 9R squared equal to 9 minus 5, that is 4. So 9R square you are getting is how much? 4. 9R square you are getting 4. So R square equal to 4 by 9. Okay? R square you are getting 4 by 9. So ideally R will be plus minus 2 by 3. Okay? We'll take the square root. This is a square, so we'll take plus minus 2 by 3. Now the question is, since it is given that the sum to infinity is 3. So in this case, R should be less than 1. Because we are taking A 1 minus R means R is less than 1. So we will not take the positive value, we will take R equal to minus 2 by 3. Otherwise we will not get the infinity sum. Sum of the infinity series is only possible in case of infinite geometric series. It is only possible when R is less than 1. R greater than 1, you will not have geometric series, infinite geometric series. Okay. So this is exercise 6C number 4. And now I will take up some additional problems. Okay. So let's take some additional problems. I'll wrap this part. Okay. These additional problems are from the exams which have come in the CA Foundation exam, as well as from the MTPs. Okay. Let me take the first one. If the sum of n terms, this is a mix of AP and GP, okay, I am mixing AP and GP. If the sum of n terms of an AP is 3n square minus n, okay, the sum of n terms is equal to 3n square minus n. Very good. And its common difference is equal to 6. What is the first term? Okay, what is the first term? So, the sum of n terms is given 3n square minus n, and the common difference is given 6. You have to find out the first term, that is A. Now we know in case of AP, this is an AP. Please note this is an AP. The sum is an AP. So we will use this formula. N by 2, 2a plus n minus 1 into d. So let's take any number. Let's take n for n4. Let's take n equal to 4. Let n be 4. Okay. Let n be 4. Then what is the formula? It will be 4 by 2, 2a, a we don't know, plus 4 minus 1 into d. D is 6. This formula, if you put n equal to 4, this will be the result. Now this is equal to 3n square minus n, and n is 4. So 3 into n square, 4 square minus 4. So this becomes 2. So you get, from here you get 2, 2a plus 4 minus 1 is 3. 3 into 6 is 18. This is equal to 4 squares are 16. 16 threes are 48. 16 threes are 48. Minus 4 is 44. Okay, I hope you are going correct. So 2, this will become 22. So we have 2a plus 18 equal to 22. So 2a is equal to 22 minus 18, that is 4. So a is 2. So this was the question. What is the value of a? What is the value of a? We have achieved. The value of a is 2. Now many of you were asking that why I have taken n equal to 4. Okay, many of you were asking me in the question, why n4? You can take any number. You can take n equal to 3. The same result will come. You can take n equal to 2. Okay, because if I am taking n4, then 4 minus 1. If it is n3, then it will become 3 minus 1. Any value of n can be taken so that you reach the same result. Okay, so there is no hit or trial method. You can take any number. Fine. So this was additional problem number 2. Now you will see a lovely problem. Okay, I'm sure you will enjoy this problem. So this one was an AP. Now let us go to a GP problem. GP problem, and I have a ball. Okay, now let's have some. Why only study? Why not play also? So I have a ball, and this ball is very special. You have Kalia here, and you have okay, some fictional characters here. Okay, so I'll play. It's time to play. The question is, if I drop a ball, okay, the ball bounces back. Okay, I drop a ball from a height. It bounces back. And now see the question. A certain ball is dropped from a height of 100. It's dropped from a height of 100 meters. Okay, the ball is dropped from a height of 100 meters. It bounces up to 4/5 of the height. Again falls down. Again bounces up to 4/5 of the height. Again falls. Again 4/5. So if you bounce a ball, like this. Okay. So you know if the ball is going up and down, bouncing up and down. So the question is, if the ball is dropped from a height of 100 meters, it's a lovely question. If the ball is dropped from a height of 100 meters, this is the ball is getting dropped from a height of 100 meters. The ball drops, goes up to how much? 4/5 of the original height. Please see the problem. The ball goes up to 4/5. So this height, h, 1 is 4/5 of h. This is h, that is 100. Again the ball drops, goes up to 4/5. H2 will be 4/5 of h1. Again drops, so in this way it will go up and down, and it will ultimately end somewhere. Okay? So the ball which you see here will bounce up. It will bounce to 4/5 of the height. I am dropping from here. It bounces up to 4/5. Again it falls, again to 4/5. In this way it will go on. Okay? I hope you get this problem. That's why you have some time to play also. Okay? And maths is fun. Okay, so here it falls from here, goes to 4/5 of the height, again falls, again 4/5, again falls, again 4/5. In this way it goes on. Of course, the ball falling from the height and going up depends on the elasticity of the ball, and we use a coefficient of elasticity. That's of course physics, not going into it. Now the question is, how long, what is the total distance the ball will travel? Up and down. The total distance is from here it comes, again goes up, goes up, comes down, goes up, comes down. In this way the total distance, what is the total distance it travels before coming to rest? Okay, so we have the ball, you have to think. So what will be the answer? So we have so much of, many of you love cricket, many of you play with these type of balls, and now question is apply mathematics. What do we do here? First of all, options are given, but you can see here it is assumed that the ball comes down, goes up, comes down, goes up, comes down, and goes on till infinity. Till infinity. We don't know when it will stop. Theoretically speaking, not practically, theoretically, under ideal conditions. Under ideal conditions, if the ball is perfectly elastic, then it will never stop. You know, there in physics, we have something called the conservation of energy principle, which says that energy can be converted from one form to the other. You cannot create energy, you cannot take away energy. So ideally the ball will continue till infinity. It will never stop. But it stops in real life because of frictional forces. Okay? Maybe the ground is rough. So the ball ultimately stops because it will not bounce up to 4/5 of the height every time. It will bounce up because plus you have resistance of the air current coming in, and so the ball ultimately stops. But ideally speaking, the ball will fall, go up 4/5, fall, go up 4/5. It will go on till infinity. So dear friends, why am I focusing so much on infinity? Because it is a problem of infinite GP series. It is an infinite GP series. Here, 4/5 of the height means what? R is 4/5. So I write R is equal to 4/5. Right? R is 4/5. And therefore, what exactly happens? Let's see. Let's analyze. The first time it falls is definitely from a height of 100 feet. So 100 plus. Okay, be very careful. Now I have kept away the ball, no more playing. Kept away the ball. It's time to concentrate. So 100 plus. Now the ball comes down here, 100 meters it has covered, now goes up to 4/5. 4/5 of 100 is 80. Again comes down 80. So plus 80. Again goes up to 4/5 of 80. Now 4/5 of 80 is 16, 64. So 64. Again comes down 64. Again goes up to 4/5 of 64. In this way it moves on. Okay. So I can write this in a particular form, and the form is 100 plus 2 into 100 plus 2 into 80 plus 80 into 4 by 5 into plus 80 into 4 by 5 square, and so on till infinity. Till infinity. So now we have got this expression 100 plus 2 into, because you see 80 and 80, so I am taking 2 common. 64, 64, I am taking 2 common. And 64 is nothing but 80 into 4 by 5. Right? So it becomes an infinite GP series. In this GP series, if you look at this part, okay, if you look at the lower part, then what will be the value? Infinite GP series value is A divided by 1 minus R. A divided by 1 minus R. So A we know. A here is 80. So we take A as 80. I will take A as 80. Let's compute this part. A equal to 80. R is 4 by 5. So this portion, infinite GP series, the formula is what? The formula is given by A 1 minus R. A divided by 1 minus R is the formula which is given. A divided by 1 minus R is the formula which is given. Here A is 80. 1 minus R. R is 4 by 5. So 1 minus 4 by 5. That means this is equal to 80 divided by 1 minus 4 by 5 is 1 by 5. So 80 divided by 1 by 5. That means 80 into 5, which is 400. So this is 400. But you have 2 outside. So this entire value is 400. But you have 2 outside. So 2 into 400, that is 800. Plus this original 100. So you have 100 plus 2 into 400. That is 100 plus 800. That is 900. 900 meters. The answer is 900 meters. Assuming it's like a infinite GP, right? Fine. So this was, I think, a classic example. Now we'll take, this is an additional problem. We'll take on AP. So this, I hope you understand the graphics and the picture here, how it is falling. It's going up. Why we are multiplying by 2? So 100. It falls down, 80, it goes up, again comes down 80, 64, again comes down 64, so 2 times. And ultimately the amplitude, this is what is called the amplitude. I was showing you the sine curve. This is the amplitude. Amplitude reduces, slowly it reduces, dies down. Okay, fine. I wrap this up and we'll take up the next question. Fine. I'll take up 2 more questions and then we shall be ready to complete this chapter and move on to the revision and the questions which have come on arithmetic progression. So I'll take many of these queries you'll sort out. 3 and 18 is given. 3 and 18, you have to insert 4 arithmetic means. 4 arithmetic means between 3 and 18. You have to insert 4 arithmetic means. So 1, 2, 3 and 4. Fine. Let's work on this. 3 and 18 given and you have to insert 4 arithmetic means in between 3 and 18. Fine, how to do? So we have inserted this. So here we have term 1. So it's an AP. Please note it's an AP. So term 1 equal to 3. And the common difference is assumed to be D. D for delta, D for delta. So D is D. 4. You have 4 numbers here. So these are the 4 arithmetic means. That means 3 is term 1, 2, 3, 4, 5, 6. Term 6 is 18. We know from this formula, term 6 in an AP is equal to A plus 6 minus 1 into D. A you know is 3, A is 3. So 3 plus 6 minus 1 is how much? 5. 5 into D. This is equal to given 18. So 5D equal to 15. 18 minus 3 is 15. Therefore, D is equal to 15 by 5, that is 3. If you get D equal to 3 and you know the first term is 3. So the second term T2 will be A plus D, that is 3 plus 3, 6. Second term, third term will be equal to 6 plus 3, that is 9. And fourth term equal to 9 plus 3, that is 12. And fifth term is 12 plus 3, that is 15. So the 4 arithmetic means which you need to insert between 3 and 18, the answers are 6, 9, 12 and 15. Okay, I hope this is clear. So you take the 4 numbers in between and accordingly you get the last digit, the last number you show it as term, in this case T6. T6 we know the formula, A plus 6 minus 1 into D, and the rest follows. Naturally you get the 4 arithmetic means. Okay, now we'll take a question combining AM and GM, arithmetic mean and geometric mean. Okay, let us take the problem. The problem is, please note the problem, that there are two numbers. Find the numbers. Okay, the two numbers, arithmetic mean. So, two numbers where arithmetic mean is 12.5. Okay, and their geometric mean is 10. What are the numbers? Okay, so you have their arithmetic mean is given 12.5 and their GM is 10. Geometric mean is 10. We have discussed both about arithmetic mean and geometric mean. How do you do it? So let us assume the numbers are X and Y. Two numbers X and Y. So arithmetic mean is 12.5. So I can write the mean of two numbers. The arithmetic mean of two numbers is what? X plus Y by 2. This is equal to 12.5. So X plus Y by 2 is equal to 12.5. This is the first equation. And their GM means the square root. So root over XY equal to 10. This is equation 2. So please see the equations. X plus Y by 2 equal to 12.5 is 1. And root over xy by 10 equals, this is equation 2. So if you now try and solve, from this equation we get x plus y is equal to 12.5 into 2, that is 25. And from this equation, if you remove the square root sign, if you square both the sides, you get xy equal to 100. So you have x plus y is 25 and xy equal to 100. So from x plus y equal to 25, you get x is equal to 25 minus y. 25 minus y. Y comes to this side. Okay? Following? I hope you are following. All there? Okay. So you have x equal to 25 minus y. Put this value here. Instead of x, I write 25 minus y multiplied by y gives me 100. So this is 25y minus y square equal to 100. If you simplify it, it takes the form of a quadratic equation. You get y square minus 25y minus 100 equal to 0. Plus 100, sorry. We are taking everything to the right hand side. So y square minus 25y plus 100 equal to 0. So I'll solve the equation here. Just writing it here. Y square minus 25y plus 100 equal to 0. Quadratic equation, again we go back to the basics. We talk about alpha, beta, the roots. We have to split the middle term. You can do it like this. Y square minus 20y minus 5y plus 100 equal to 0, which means this is y minus 20 into y minus 5 equal to 0. So there are two answers, either y is 20 or y is 5. If y is 20, okay, then x becomes equal to 5. 100 by 20 is 5. So the solution is this. X and y, if y you take as 20, then x becomes 5. And if you take x as 20, then y is 5. So the numbers are 20 and 5. Hope this is clear. This is a classic problem because you have both AP and GP combined. Right. What is the time? Okay. Okay. We'll take another one. Additional problem. This is again on AP. So we are completing AP and GP. So we will try and take all mixed problems. Okay. Both AP and GP. Right. So let us see. I am rubbing this part. I hope this is clear. One by one we are solving. The formula is still in front of you. you want to note down or you want to use the formula, you can do it. Okay. Now we are taking this one. There are three expressions: x plus 1, comma, 3x and 4x plus 2. 4x plus 2. Okay? These three are in AP. Okay, these three are in AP. You have to find out what is the value of x. X equal to how much you have to find out. So, since they are in AP, they will have a common difference. X, Y, Z are in AP. That means y minus x will be equal to z minus y and there will be a common difference. Okay? CD, common difference. So, the formula will be like this. 3x minus the first term, that is x plus 1, will be equal to the third term minus second term. So, 4x plus 2, third term minus second term minus 3x. So, we get a linear equation. Let's see what we can do. So, 3x minus x minus 1 is equal to 4x minus 3x, that is x plus 2. So, here we have 3x minus x is 2x minus 1 equal to x plus 2. That is 2x minus x is equal to 2 plus 1, that is 3. That is x is equal to 3. So, we have got x equal to 3. This is the answer. For x equal to 3, these three expressions will be in an AP. Okay? Right. Now we take the last one, additional questions. This is another, you will see a classic one. This is easy. I hope you have followed it and feeling relaxed. Okay, this is the last one. Then we shall move on to the queries and some of the questions I'll solve in front of you. Many of you had some questions on arithmetic progression. We'll solve. This one was an easy one. You have three numbers, three expressions given, which are in AP. And you have to find out the value of x. So, I assumed that they are in AP. So, there is a common difference. So, term 2 minus term 1 we did here. And term 3 minus term 2 I did here. So, once you simplify, you get x equal to 3. Now, I shall take a little bit tricky one. This is the last additional problem on AP GP. And please do with me. This is going to be a very classic one. It is given if a to the power 1 by x, a to the power 1 by x is equal to b to the power 1 by y is equal to c to the power 1 by z. Fine? A to the power 1 by x is equal to b to the power 1 by y is equal to c to the power 1 by z. And the other condition is a, b and c are in GP. Great. Then you have to find out what is the relation of x, y and z. Are they also in GP? Or are they in AP? What? Or are they not related at all? You have to find out. Beautiful problem. Okay? A to the power 1 by x equal to b to the power 1 by y is equal to c to the power 1 by z. Looks a little bit clumsy and critical. What to do? Let's take it head on and just applying common sense. So, let us equate. So, we have a to the power 1 by x is equal to b to the power 1 by y equal to c to the power 1 by z. Let it be equal to k. K is a constant. Okay, I take a constant k. Fine? Great. Following? So, I get a to the power 1 by x equal to k. So, a is equal to what? K to the power x. This I assume you have good idea of indices and you remember the formula of indices. A to the power 1 by x, if it is equal to k, then a will be k to the power x. Similarly, b to the power 1 by y equal to k. So, b is equal to k to the power y. And c to the power 1 by z is equal to k. So C is equal to K to the power Z. PC. So now we have got the value of A, B and C and we know they are in GP. If three numbers are in GP, A, B, C are in GP, then we know that B by A will be equal to C by B if they are in GP, which means B square will be equal to AC. B square, B into B equal to A into C. B square is equal to AC. So now we have got the value of A, B and C. Let us put the values here and see. So B is K to the power Y, but I need B square. So I write K to the power Y whole square. This is equal to AC. A is how much? K into to the power X. And C is K to the power Z. So into K to the power Z. Friends, you know A to the power M, okay, into A to the power N is equal to A to the power M plus N. So same thing, K to the power X into K to the power Z, this will be equal to K to the power X plus Z. And you know K to the power Y square means what? This is actually K to the power 2Y and on the right hand side we have K to the power X plus Z. So we are getting K to the power 2y is equal to K to the power X plus Z, which means the relation is 2y equal to X plus Z. 2y equal to X plus Z means easily that the numbers X, Y and Z are in AP, because if three numbers are in AP, if X, Y and Z are in AP, then Y minus X will be equal to Z minus Y, or 2y will be equal to X plus Z. So since we have got the same expression here, then we can easily infer that X, Y, Z are in AP, provided if A, B, C are in GP, X, Y, Z are in AP. Classic case, lovely question because it combines three chapters, AP, GP and indices. Okay, fine. With this we complete our GP part and I'll take few questions from AP. I think I'll wrap this part. We have the formula beside us. I'll take some tricky ones, some of the tricky questions, and I've also done how to insert. I have shown you how to insert arithmetic mean and geometric mean. So there was a question from Anusri from Kerala and Fatima from Vadodara. The question was insert 4 arithmetic means between 4 and 324. Okay, from Fatima from Vadodara and Anusri from Kerala, and this is exercise I think 6, example 6. So example 6 from the study material, 4 arithmetic means. Okay, I am not doing the entire problem, I think you can do it. We are inserting 4 arithmetic means here between 4 and 324. 4 arithmetic means, automatically you using the formula, this becomes A, first term, second term, third term, fourth term, fifth term and sixth term. So 324 is term 6 and term 6 we know T6. If you write T6, T6 is equal to A plus N minus 1, that is 6 minus 1 into D. So using the formula, you get the result 68, 132, 196 and 260. These will be the answers. I hope Anushree and Fatima, you can just solve it on your own, because I have done similar problems today and this is of the same form. Just put the formula and you will get the value of the D here. Once you get the value of D, because A you know is 4. So this is nothing but 4 plus 5D. This is equal to 324. In fact, from here you will get 5D equal to 324 minus 4, that is 320. So D will be 324 by 5, that is 320 by 5, that is 5 6 are 30, 64. So D is 64, the first term is 4. So second term is 4 plus 64, that is 68. Third term is 68 plus 64. Okay, 68 plus 64 is 132. 132 plus 64 will give you 196. Okay, and 196 plus 64 will give you 260. Okay, So we have solved it. Next one is from Navya, exercise 6A number 1. Okay, rubbing this up. Exercise number 6A number 1. So this is a question which has come from Navya. Sequence is given 1, 3, 5, 7. We have to find out the nth element. We have to find out the nth element. Well, Navya, this is easy and I hope you can do it on your own. Just now with the discussion we had today, I think you can do it. Just showing you, here it is a AP. It is an AP because you have a common difference of 2. 1, 3, 5, 7. Common difference is 2. Okay? And you have A equal to 1 and B is 2. You have to find out the nth element in the series. So nth element is this formula, A plus n minus 1 into D. So A is 1 plus n minus 1 into D. D is 2. So this is equal to 1 plus 2n minus 2. 1 plus 2n minus 2. That is 2n minus 1. This is the answer. 2n minus 1 will be the answer. I hope, Navya, you have got your answer and others also must have gained. Next question has come from Anurag Agarwal, Bulandshahr and Hema from Tamil Nadu. What is the formula for the first n even numbers? I have already answered it here. Even numbers, the formula is n into n plus 1. So Hema and Anurag Agarwal, I hope you have got your answer. The next one is from Vanshika, Punjab. She often writes to me, Sanjana Talekar from Mumbai and from Yuvraj from Agra. So the question is, they have given a question here. I'll just write it here. The nth element. Okay. The nth element in the sequence. Here the sequence is minus 1, 2, minus 4, 8 and so on. What is the nth element in this series? Okay. In this sequence. Sorry, not a series. Sequence. Please note, this is a question from Vanshika from Punjab and Sanjana Talekar from Mumbai and Yuvraj from Agra. Now this is nothing but a GP. Here A is equal to minus 1, the first term, and the common ratio is 2 by minus 1, that is minus 2. Okay? So we have to find out the nth element. The nth element is given here, A r to the power n minus 1. So A is minus 1, R is minus 2 to the power n minus 1. So this is nothing but minus 1 into minus 2 gives you 2. 2 to the power n minus 1. Right? This is as simple as this. Fine. Solved. Okay. Now we have a question from Alan D'Souza. Exercise 6A number 3. Okay. Exercise 6A number 3. I am rubbing this part. Hope our friends have got their answer. The question number now is exercise 6A. Exercise 6A number 3. Exercise 6A number 3. The question is from Alan D'Souza from Mumbai, Tanvi Jain from Agra, Bharat KR from Chennai, Shivam from Delhi and Aditi Tiwari. Okay, so 5 of them have sent this question and I thought of doing it here so that everybody benefits. The question is number 3, exercise 6A. Again sigma. Okay, sigma 2 square root of 2i minus 1 and sigma is I equal to 4 to 7. Looks very, very intimidating. But whether you are from maths background or not, just take it, just chill out and be cool. Don't get unnerved with this type of expression. Break it up. Okay, using logic. So, this actually summation means what? That for I from 4 to 7 we have to add. That means what we have to do is, the first expression will be 2 into, instead of I is 4 to 7. So you have to put the value I4, I5, I6 and I7. There will be 4 numbers. Okay. So we will put I equal to 4 here first. So 2 into 4 minus 1 plus again square root 2 into 5 minus 1 plus again square root 2 into 6 minus 1 plus again square root 2 into 7 minus 1. So 4, I have given 4 here, 5 is here, 6 is here and 7 is here. So 4 to 7, sigma, summation, 4 to 7. Please see, once again, see the expression. Fine? Okay, so we break it up. Simple. 2 into 4 is how much? 8. 8 minus 1 is 7. So we have root 7 plus 2 into 5 is 10 minus 1 is 9. Root 9 plus 2 into 6 is 12 minus 1. Root 11 plus 2 into 7. 14 minus 1. Root 13. So, dear friends, this is the answer. Root 7 plus root 9 plus root 11 plus root 13. The question came from Alan D'Souza, Tanvi Jain, Bharat KR and Shivam from Delhi as well as Aditi Tiwari. Hope you are all clear with this and others are also absolutely cool with this answer. Okay, now we have a small problem. Exercise 6A number 4. I am rubbing this solution. Right, we are doing full analysis like the other days also. Right, we have already crossed 4 o'clock, nearing 4:30. We are working hard and going strong. 6A number 4. Question has come from Diksha Sain and Yuvraj from Agra. There is a question minus 5, 25, minus 125, 625 till infinity. Right. So, what is the formula? What is the sum? Sum to infinity. So, to infinity. We know the formula, sum to infinity equal to A by 1 minus R. Here A is minus 5. 1 minus R. R is 25 by minus 5. That is, it is also minus 5. So, minus of minus 5. So, we have minus 5 numerator and 1 plus 5. Right. So, it becomes 1 minus 1 plus 5. So, it is minus 5 by 6. Okay, sum to infinity. I'll take the next one. This has come from a good number of students. I must do it in front of you so that you can get this. Nail it. Okay. This has come from record number of students. Exercise 6A, number 8. So many of you wrote to me requesting me to take this problem. Okay. Sumit Kalra, Aditi Tiwari, Kishan J, Arnav Bajaj, Shivani Priya, Rohit Agarwal, Dhanu Jirawala, M. Sudarshan and Bhavna. Good number of people. Again, it's a problem which looks a little bit crazy, but it is not that crazy. We will nail it. Right? See the problem. The mth term of an AP is n. Okay, I write. It's an AP. The mth term is equal to n and the nth term equal to m. Then rth term is how much? Please see the problem once again. AP is a question of AP. The mth term you have to find out. Mth term is given n. And the nth term is m. Rth term you have to find out. So let's try out and see what we can do with this. So let term 1 be A and the common difference is D. It's an AP. So I take common difference as D. Mth term, that is Tm, will be A plus m minus 1 into D. Formula is here. Tn. This is equal to n because it's given. Tn, nth term. Okay, A plus n minus 1 into D. This is equal to m. M. Okay. So, if you just now question of adjustment, right? We subtract both the equations. So, what do we get? A plus n minus 1 D. A plus n minus 1 D. N and m. So, A minus A gone. So, we are getting m minus 1 D minus n minus 1 D is equal to n minus m. Please follow carefully every step. Please follow carefully. Mth term is n, nth term is m. Okay? M for Mike, N for November. Phonetically speaking. M Mike, N November. Okay? we have to find rth term, R Romeo. So you know the phonetic alphabets. Okay. So M is Mike, N is November, R is Romeo. So we have to find out the rth term. So from here we are getting this expression. So M minus 1D minus N minus 1D. I am taking D common. So you are getting M minus 1 minus N plus 1. This is equal to N minus M. Minus 1 plus 1 cancels out. So you are getting D into M minus N. M minus N. This is equal to N minus M. So N minus M and M minus N is reverse. So you cancel, but there is a minus sign now, it comes up. So D will be equal to minus 1. Okay. Till now, just see if you understand. So D is equal to minus 1. Okay, I rub this part again and just continue. So D comes to minus 1 and mth term is N, nth term is M. So we have to find the rth term. D comes to minus 1. Okay. So my question is, if D is minus 1, then from this equation, I am highlighting the equation, from this equation, okay, from this equation, we will put D equal to minus 1 here. And what do we get? A plus M minus 1 into minus 1 is equal to N. Which is A plus M minus 1 into minus 1. Okay, M minus 1 into minus 1 means it becomes minus M. Just I'll rub this. It becomes minus M plus 1 equal to N. In other words, A becomes, from here if you see, A becomes, just see what is the value of A. From here, A becomes M plus N minus 1. So we have got the value of D. D is minus 1. And we have also got the value of A. A is equal to M plus N minus 1. D we have got, A we have got. Now we have to find the rth term. What is the rth term? Okay. So let us write the rth term, R. So TR, rth term, will be equal to A plus R minus 1 into D. A plus N minus 1 into D, same thing, A plus R minus 1 into D. Okay, you are following? This is the toughest one in fact, today, toughest problem. Okay, so A plus R minus 1 into D, but A we know is M plus N minus 1. So I write M plus N minus 1 plus R minus 1 and D we know is minus 1. We have calculated D as minus 1. So minus 1. So let us simplify. This is M plus N minus 1 minus R, minus 1 into R is minus R plus 1. Minus 1 into minus 1 is plus 1. So this plus 1 cancels with this minus 1. So the answer is M plus N minus R. This is the answer. TR is equal to M plus N minus R. Okay. This was the toughest problem. So I solved it step by step so that you know how to solve these type of problems. Mth term is given. From there, nth term is also given. So first you write the equations and by cancellation you are able to get D equal to common difference. D is minus 1. That is the end of the first step. Then once you get D, find out the value of A. Once you have the value of A, put them and you will be getting the value of rth term. Okay. In some of the questions, I had taken n equal to 2, n equal to 3 and I explained that you can take any number. So there was a question from general query came. I am not going to that. Okay. Next is 6A number 19 I am solving. Okay. So I am solving number of problems already. Let's take number 19. 6A number 19. The request has come from Utkarsh. He also writes very often. And Diksha sign. Okay. 6A number 19. The question is the pth term. The pth term of an AP is 3p minus 1 by 6. Okay. So the pth term, TP, okay, pth term is equal to 3p minus 1 by 6. This is an AP, please note, not a GP but an AP. What is the sum of the first n terms? Sum of the first n terms. We don't know. We have to find out. So, PP is given is 3p minus 1 by 6. This is a generic term. So, if p equal to 3, this I'll put p equal to 3 here. If p equal to 4, I'll put p equal to 4 here. As simple as that. So, let me take p equal to 5 and see what happens. So, first point, let p equal to 5. So, I want to find out the pth term. The pth term by definition is a plus p minus 1 into d. Right? So, I write a plus p minus 1 into d. But from the given problem, 3p minus 1 by 6, I put p equal to 5. So, I get 3 into 5 minus 1 by 6. That means a plus p minus 1 into d is equal to 15 minus 1 is 14. 14 by 6. That is 7 by 3. So, I get an equation, first equation. The second equation, right, let p be equal to 8. I am taking p equal to 8. So, let p equal to 8. These numbers, once again I am repeating friends, these numbers, whether you take 5, 8, 3, 4 is up to you. Any number you can take, it will give you the same results. So, please don't think that I am taking 5 and 8, there is some rule. No rule. You can take any number. Okay, as simple as that. So, let's solve it and see. So, for p equal to 8, it will be a plus, okay, here p, instead of p I will write 5 because this was 5. Okay, so I will write 5 minus 1 into d. Here for p equal to 8, I will write a plus 8 minus 1 into d. This will be equal to, I will put 8 here. So 3 into 8 minus 1 by 6. That is 23 by 6. So we are getting two equations. A plus 5 minus 1, 4d. Rather, 3 into a plus 4d is 7. Or I will put it like this. Let it be like this. I'm going to multiply. A plus 4d. A plus 4d is 7 by 3. And we are getting a plus 7d. 8 minus 1 is 7d. This I am getting 23 by 6. 23 by 6. So, if this is 1 and this is 2. So, if I subtract, if I do 2 minus 1. Okay, 2 minus 1 if I do, I will get what? A and A cancels out. 7d minus 4d. Okay, 7d minus 4d is how much? 3d. 3d is equal to 23 by 6 minus 7 by 3. 23 by 6 minus 7 by 3, that is minus 14 by 6. That is 9 by 6, that is 3 by 2. So we have got 3d equal to 3 by 2. If 3d equal to 3 by 2, then we are getting d is equal to half. So we have got d equal to half. Okay, we have got d equal to half. Now we have to find the value of a. Right, I am rubbing these equations. We have to find the value of a. We have got d is equal to half. Okay, now we had an equation for p equal to 5. We had an equation a plus 4d equal to 14 by 6, that is 7 by 3. Because we had 3 into 3, 9. Sorry, I will just check. Yes, please raise a 9 minus 1. For 3 we took 3 equal to p equal to 3. 5. Okay. For p equal to 5. Okay, a plus 4d. So just once again I will solve. A plus 4d equal to 3 into 5 minus 1 by 6. That is 14 by 6. Okay. And we have got d equal to half. So d equal to half if I put. So I am getting a plus 4 into half. This is equal to 14 by 6. This becomes 2. So a I am getting 14 by 6 minus 2. That is I am getting 14 minus 12. That is 2 by 6. So a is equal to 2 by 6, which is 1 by 3. So a equal to 1 by 3 and d equal to half. These two values we have got, right? So we have to find out the last one, what is the sum? The sum is given by this formula, n by 2, 2a plus n minus 1 into d. So I'll be putting the same values here. The sum equal to n by 2, 2a, that is 2 by 3 plus n minus 1 into d is half. So if you simplify this, let us do it. 2 and 2 cancels out. So we get n by 3 plus n into n by 2, that is n into n minus 1 by 4. 2 into 2 is 4. So we take the LCM, 3 and 4 is 12. Please follow us. So you get 4 times 4n comes in the numerator plus 4 into 3 is 12. So you have 3n into n minus 1. So this is the final expression which I will now wrap up here. Okay, so number 19, the final expression comes to 4n plus 3n into n minus 1 by 12. This is equal to 4n plus 3n square. 3n into n is 3n square minus 3n. 3n into minus 1 is minus 3n by 12. So this is 3n square plus 4n minus 3n, that is plus n by 12. This is the final answer. Okay? So this gives you the final answer. This is exercise 6A number 19, a little bit stiff one. That's why I solved it. Okay. Similarly, exercise 6A number 21, insert 4 arithmetic means between minus 2 and 23. Same way, you just give the 4 boxes. 4 arithmetic means, that means 23 will become the 6th term. This was a request from Madhusudan Kabra. I think you can do it now on your own. Okay. The last question is, I will take this up, and this has come from Kriti Kumari and Madhusudan Kabra, exercise 6A number 23. The last one, exercise 6A number 23. Let us try this one and see if we can get right answer and solve it. Exercise 6A, the question is 23. Let's write the 23rd question. There is a series, AP series, minus 8, minus 6, minus 4, so on, and the sum is 52. The sum comes to 52. Okay, the sum comes to 52. Till n terms, of course, minus 8, minus 6, minus 4, minus 2, like this. What is the number of terms when the sum becomes 52? Okay, so here you can see a equal to minus 8. The first term is 8, minus 8. Common difference d, minus 6, minus of minus 8. So minus 6 plus 8, minus 6 plus 8, that is 2. So the common difference is 2. First term is minus 8, common difference is 2. We have to find n. Okay, so let's put the formula, right? So sum we know is n by 2, 2a. 2a is minus 8. So 2 into minus 8 plus n minus 1 into d. d is 2. This is equal to 52. The 52 is given, 52. So if you simplify, you get n by 2 minus 16 plus 2n minus 2 equal to 52. So here I simplify further, n by 2. 2n minus 16 minus 2, that is 2n minus 18 equal to 52. This becomes, I'll take 2 common, I'll bring 2 outside. So 2 into n by 2, I get n minus 9 equal to 52. This 2 cancels with this 2. So I'm getting a quadratic equation. Please note, a quadratic equation. I'll solve it here above. Okay, I'll solve it here. So the quadratic equation I'm getting is n into n minus 9 equal to 52. n into n minus 9 is 52. That means n square minus 9n minus 52 is 0. n square minus 9n minus 52 is 0. If you solve for this, what will you get? Okay, n square minus 9n minus 52 equal to 0. Okay, so you are getting n square minus 13n plus 4n minus 52 equal to 0. I am splitting the minus 9n part into two parts, minus 13 plus 4. So this gives me n into n minus 13 plus 4 into n minus 13 equal to 0. That is, the equation is n minus 13 into n plus 4 equal to 0. Now n can, from this equation, n minus 13 into n plus 4 equal to 0. From here you can draw two conclusions. First, n is equal to 13 or n is equal to minus 4. But can n be minus 4? Because n is number of terms. It can never be negative. So n minus 4 is not possible. It is not admissible. It is not acceptable. It is not logical. So n has to be equal to 13. So the answer is n equal to 13. Right? I hope Kriti and Madhusudan, both of you have understood. This was a tricky one and that's why I solved it. Friends, the last question is not from this chapter. It is from exercise 5B, but I will take it because I did it last day. In fact, a question, if you see the request, initial request came from Tejaswini P from Karnataka, Kajol Singh from Rajasthan, Anushka Mishra from Delhi. Now again, after solving it last day, again some people did not understand. So we have Vanshika, Madhusudan Kabra, both of them have raised a question on this question, the solution. So I will try to clarify. Okay, why I solved in this way. The question is exercise 5B. Exercise 5B, B for Bravo. Exercise 5B, question number 19. Right, let's open this. I am taking this up at the end because we have solved all problems of AP and GP and I clarified almost all of the doubts. So the last question, this I did last day. You may remember the question was 6 positive signs and 4 negative signs. In how many ways they can be arranged in a line? Okay, 4 positive signs, 4 negative signs and 6 positive signs. 6 positive signs and 4 negative signs, how many ways they can be arranged in a line so that the 2 negative signs will never come together. The question came, the further query has come from Vanshika and I think she is from Punjab, and Madhusudan Kabra from Rajasthan most probably. So they have raised this question. First of all, let us see how we can fit these signs. Okay, 6 positive signs and we have 4 negative signs. So let me first write the 6 positive signs. Now the question is 6 positive signs, 1, 2, 3, 4, 5, 6. The question came from Vanshika and Madhusudan. First question was why we are doing combination. Well, it's a combination problem because here the order does not matter. Minus signs are same. Whether you put minus minus or you put this minus this side doesn't make a difference. So the order is not relevant, so combination. I hope you get it. Second question has come, why 6 plus signs is okay. Now we have 4 minus signs. How can you place the 4 minus signs so that 2 minus signs will never be together? This is the point where Madhusudan and Vanshika had a problem to understand. I am trying to solve the problem. I hope Vanshika and Madhusudan, you are watching this, and this question also came from Tejaswini, Kajol Singh and Anushka Mishra. Now if you see, I can put the 4 negative signs in how many places? Either here, or here, or here, or here, or here, or here, or here. How many places? I have 4 negative signs. 6 positive signs I have already placed. Okay, so I have 4 negative signs. I think Madhusudan and Vanshika had an issue to understand, couldn't understand one point, which I am trying to clarify. They probably they thought that if it is 6 signs, 6 positive signs and 4 negative signs, then why I am taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. Altogether 13 places. Why? If it is 6 positive signs and 4 negative signs, why sir is taking 13 places? Why? Madhusudan and Manshika, kindly observe, and others also, that I have got 4 negative signs, 4. But I can place them in how many ways? 1, 2, 3, 4, 5, 6, 7 ways. So, if I put them in 7C4, automatically the others can be placed. Because the order does not matter. Therefore, 7C4 will be the solution. 7C4 means 3, 2, 6 cancels out, it is 35. So, it is 35 ways. Okay? I hope Madhusudan and Vanshika, you have now understood that even though we have 4 signs, we have 7 options. Okay? For these 4 signs. So, 7 circles plus the 6 positive signs. 7 and 6 gives you 13. I now hope that you understand why we have altogether 13 vacant places where we can place them. Even though the total number of signs is 10 and 4. Okay, sorry, 6 and 4. So for 10 places, we are actually having 13. Right. This was the last one. I'll take just 5 minutes more. We'll cover complete by 5. Utkarsh had a question whether the questions will be formula based. Mostly yes. Okay. Kunal from Chennai, what do you mean by arithmetic mean? I think you now explained. You explained. Faizan from Jammu and Kashmir was asking, in certain numericals I took value 2 and 3. I explained it that I took 2 and 3 just as an assumption. You can take any other number, 3, 4, 5. Same result will come. Okay. Yes, Gagandeep Kaur from Tagore from Siliguri had a question. Why we are not considering -3 in case of a particular GP problem? Yes, you can take the -3 also. The answers will be different in that case. Okay, Manav also had the same question. Suhani Patel, yes, minus question, negative question, I mean positive and negative sign. She had the same question. It is, I have answered it. Okay, then we have Jyoti Singh, marks weightage I have discussed. Urvashi, weightage in the subject. Urvashi from Lucknow I have discussed. Okay, Gagandeep Kaur Tagore, where to find MTP? MTP you will get from the ICAI knowledge portal, Board of Studies knowledge portal. Please download May 2020 MTPs. Okay, Anjana Ashokan, is there a shortcut to calculate SN? No, formulas are given here. These are the shortcuts. There is no further shortcut. For example, for even numbers it is n into n plus 1. For odd numbers n square. So this at least you need to remember. Okay. Then Yojisha had a question. I request you to directly talk to exam department. You had a question. Sequence and series are the same. Yojisha J from Chennai. I think I have answered it. Sequence is the different numbers which has an order, but series means the summation of the different elements of the series. And you have said that you are liking the classes. Thanks for that. Rohan Kumar Konda again thanking me. Thank you. Okay. Tejashree. Okay. Yes. So I have answered your question. You had a question regarding MTP number 32. I have answered it. You will get it. I am sure you will be getting it in the portal. The answers will appear in the portal. Riya Kumari. Okay. Why I have taken P equal to 5 and 8? Well, you can take any number. Okay. Aman Goel from Delhi had a question. How to manage the time in the exam? Well, some of the questions are lengthy, but I would suggest, Aman, you start with the easier questions first. Once you complete them, you take the more difficult ones. So the shortest questions you should be completing first. This will boost your time and your confidence. You will have a cool mind and you will be able to solve all the remaining problems. I am very confident. Okay. Aman also thanked for the sessions. Thank you, Aman. Okay. Jaya Durga Shekhar from Kanchipuram has said thanks for the classes. Welcome. Saloni had a question. Yes, you can take any number. Saloni. Shruti Gupta, why we have not taken D equal to 3? -3 if you take D, say D square is 9. So you can take D plus 3 as well as -3. It will give you separate set of numbers. Okay. Shruti Gupta, please discuss the other method for finding arithmetic mean. I have done it today. So if say 5 and 30, 4 arithmetic means have to be inserted. I did that. So you can take T1A is equal to 5 and 1, 2, 3, 4, 5. T5 will be 30. So I have explained that. Pritu from Shimoga had a question. Yes, sometimes yes, I have given the answer. Drushti Yadav, I think, again the same question, I have answered it. Formula for arithmetic mean, Aditi Tiwari, I have answered it. Exercise 6B, number 17, I have done it. Okay. Diksha Sain, I have also taken your question. Omkar from Bhandup, good to see. He has said, sir, we are loving the math subject. Thank you, sir. Well, thank you. I'm really finding it very, I'm glad to be part of this connect with you. I am able to connect to you, and good that you are loving maths. Also, Gobika, yeah, requesting me to write the formula. Already I have written Gobika so that you can see all the formula. Gobika S from Puducherry, and Manav, yeah, requesting me to do some arrangement, some questions on circular arrangement. I'll do it in the probability chapter if we get time. Fine. I think Tushar Datta from Dhanbad. What is finite number, Tushar? Finite is something which is countable. If it is infinite, uncountable. Okay. And Kunal from Chennai, if the numbers are decreasing, can we still call it a sequence? Yes, the numbers may be decreasing. You might get a number like my series, sequence like this. -5, -10, -15, -20. It is still a sequence even though the numbers are decreasing. Can a sequence have a negative difference? Kuldeep from Jammu. Yes, it can have. Deepak K from Bangalore thanking me for the classes. Thank you, Deepak. Best wishes. I surely hope you'll all do well. Aditi Jain from New Delhi thanking me for the classes. Welcome, and I wish you all the best. And Indu R from Salem, you are here. She has also thanked the classes. You were able to understand the classes. Well done. Good. So friends, we come to the end of today's session. I think we did GP today. We first discussed about the exam questions, the exam weightage first. We also talked about the type of questions you will be getting in the exam, the marks distribution for the business mathematics part. We went into GP. We talked about the geometric mean, and we also used this formula, that is AR n to the power n minus 1 and the summation formula to solve different problems. And we did the problems from exercise 6C and from the remaining exercises also. And I took some additional problems. You will definitely remember the problem on the bouncing of the ball and some of the other problems where you had encountered some difficulties to understand. And at the end, of course, I took the questions and solved many of the questions from AP 6A, 6B, 6C is done, and 6D also we have taken few questions. So I hope this chapter will be clear to you. In case you have any doubts, do get back to me. And tomorrow we'll start with, in fact, we'll be taking up sets, relations and functions. That will be the basis on which we shall develop ourselves so that we can take up differential calculus chapter. So with these words, dear friends, thanks for being with me and thanks for being part of the session. I hope you have understood. Do with me as more and more you practice, you become faster, you become more confident, and you have more comfort with numbers. So thanks a lot for being there. I'm ending the session today. See you tomorrow, 2 o'clock sharp. Till then, bye and take care.